Assalamu alaikum everyone. Long time. Walaikum assalam, walaikum assalam. What is your favorite Grand Prix location? My favorite GP has to be... अच्छा सवाल पूछा है आपने, मुश्किल सवाल पूछा है. I think it has to be Monza. Good morning. Okay, good morning. Walaikum assalam. Walaikum assalam. Concepts? No. There is no time for concepts. I have a detailed playlist where I've covered all the concepts and that's it. Hello Idu. Hello Safala. It very certainly isn't morning though. 4 to 8 as per Pakistan time, which is GMT plus 5. So let's begin. So, in Expo Center, invigilator was shouting, I think you have time. If you think you have time, it is a misconception of your time. Pretty sure that did not happen. Sir, do you channel name as Q1 of today's... Yeah, what does that mean? Do you channel name as Q1 for today's stream? I'm not sure I understand. Day 5 was asking sir for a Bangladesh trip. Okay. Acha, let's get to work. Do your channel name as question Q1? You want me to rename my channel as Q1? Why? I mean, I don't see the point behind that. Chalein, shuru karte hain. Enough talk. Now let's get to work. So this PDF contains all the past paper questions from 2020 to 2025, but I haven't been able to add the marking scheme of questions from 2025. But don't worry, we will solve those questions. Okay? So let's solve some questions. Let's solve some questions from 2020. Then we will do some recent questions also. Okay? So we'll solve plenty of questions. Okay, so we'll solve plenty of questions. Don't worry about that. Before I start, I would appreciate if you guys like the stream if you haven't done that yet. And also please subscribe to the channel if you haven't done that either. Okay, did you come up with the channel name? There's a long story behind how I came up with the channel name. Now is not the time for that. Take care. Maybe some other day. All right, so question number 1. This is a question from February-March 2020, paper 5, variant 2. Achha, a lot of times students have this confusion ke how do we decide whether a question is of permutation and whether a question is of combination. So I think that's a small thing to worry about. There are far bigger things to worry about. Achha, I will not be doing the concepts. If you want concepts, then you can just watch my entire playlist of PNC. I will not be doing concepts right now. Okay? The 40 members of a club include R and S. All 40 members will travel to a concert, all right? 35 members will travel in a coach and the other 5 will travel in a car, okay? R will be in the coach and S will be in the car. In how many ways can the members who will travel in the coach be chosen? Okay, so there are 40. First of all, it says chosen. Chosen means that we're talking about selection. Selection means that we're talking about combination. Okay, selection means that we are talking about combination. Okay, now can we do 40C35 considering that there are 40 people in total and 35 will travel in a coach? Can we do that? What do you guys think? That's it, right? 40C35, that's it, job done? No, we can't do that. Okay, why? I'll explain. Because a couple of things have already been decided. Jaise ke, for example, out of 40, 35 members will travel by coach Okay, so out of 40, it's confirmed that 35 members will travel by coach, and it's also confirmed that out of 45 members will travel by car. Okay, that's also confirmed. Now we know that our Ranuf, I hope I'm pronouncing it correctly, will be in the coach and Said will be in the car. So that means we now only have to select 34 people for coach, and as far as car is concerned, there are only 4 people who will be traveling in a car. Okay, because there will be 5, but we only have to worry about 4. Okay? So notice that from the 40 people, what's going to happen to 2 people? That's already confirmed. Okay, so we're going to subtract these 2 people. Who are these 2 people? These are basically R and S. So we already know that from these 42 people, exactly what 2 people are going to do. One will travel in coach and the other will travel in a car. Okay, so this one that we're subtracting, this is basically R, who is going to be in the coach, and this one that we're subtracting is basically for Said, who is going to be in the car. So that means it's from these 38 people that we have to select 34. Okay, so what we're going to do is we're going to do 38 C 34, and whatever that is equal to, that's our answer. Let's see, I think it's going to be काफ़ी बड़ी value होगी. So 38 C 34, that's 73,815. That's it. That is our answer right here. ठीक हो गया? Okay, now let's do another question. Let's do question number 2. ठीक है? Richard has 3 blue candles, 2 red candles, 6 green candles. The candles are identical apart from their colors. Okay, so that means the 3 blue ones are identical, the 2 red ones are identical, the 6 green ones are identical. We don't have to select people for car. We don't have to select for car. Sawal padho na. The question says in how many ways can the members who will travel in the coach be chosen? We're only worried about the people who will travel in the coach. That's it. We're not worried about the people who are going to travel in a car. ठीक है? हमें सिर्फ कोच वालों की फिक्र करनी है. सही है? Read the question, guys. Read the question. All right? Now, next question. Next question says, so why did we subtract 1, the 35 and 5 people include? Nope. How can the 35 and 5 people include that? Because we have already decided what R is going to do. So that means we're not really selecting 34 people. Dekho, we have to select 35 for coach. If we know that Ranuf. If you know that Ranuf is traveling in a coach, that means we're no longer selecting 35 people. We're now selecting 34 people. Okay, and if we know that Said is going to travel in a car, that means we are no longer selecting 5 people. We're only selecting 4 people. Okay, so that is why, because out of the 40, we already know what's going to happen to 2 people. So we're not including them in our total. We've removed them from the total. Now we're selecting from 38. And we know that in the coach, there will be 35 people, but one person has already decided that he's going to travel in coach. So that means now we have to figure out how we're going to select the remaining 34. Okay? So yeah, read the question, guys. Read the question. Okay? Now, question number 2. Question 2 says, Richard has 3 blue candles, 2 red candles, and 6 green candles. The candles are identical apart from their colors. So that means the 3 blue ones are identical, the 2 red ones are identical, the 6 green ones are identical. ठीक है? अच्छा. He arranges 11 candles in a straight line. All right. Find the number of different arrangements. Okay, so what's the keyword over here? The keyword over here is arrangement. Arrangement is a hint towards the fact that we have to use what? We have to use permutation. ठीक है? Arrangement का मतलब that it's going to be permutation. If there is a red candle at each end, so that means we're going to start by making 11 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now the condition is that there's got to be a red candle at each end. So that means all we have to worry about is the 9 candles in between. So can I just do 9 factorial and leave it there? No, I can't just do 9 factorial and leave it there. Why? Because these 9 candles basically include 3 blue and 6 green. So that means the 3 blue candles are identical. So I'll divide by 3 factorial, and the 6 green ones are identical. So that means we will divide by 6 factorial as well. Okay, so let's work this out. 9 factorial divided by 3 factorial into 6 factorial. What's that equal to? That's equal to, अच्छा मुझे ये बताओ, Will I multiply it by 2? Yes or no? Will I multiply it by 2 considering that the red candles can be swapped? Yes or no? Question for you guys. क्या इसको 2 से multiply करना चाहिए या नहीं करना चाहिए? क्यों नहीं करना चाहिए? क्यों नहीं करना चाहिए? Why not? Because they're identical. Of course not. Because they're identical. ठीक है? So मैं ये red उठा के यहाँ रख दूँ, इसको यहाँ रख दूँ, आपको पता भी नहीं चलेगा. It's the same thing. So we're not going to divide it by 2. So the answer is simply 9 factorial divided by 3 factorial into 6 factorial, which is equal to 84. That's it. Okay? Why are we not doing this? Why are we not multiplying by 2? Because they're identical. ठीक है? So even if you do it, it's not going to make any difference. ठीक है? Okay. Now, part B. Find the number of different arrangements of the 11 candles if all the blue candles are together and the red candles are not together. So blue candles are together and the red candles are not together. Okay. How many red candles do we have? We have 2 red candles. Okay. So here's what we're going to do. We're going to do total. ठीक है. Total में हम क्या रखेंगे? The total number of ways in which the blue candles are together. Okay, so we're going to find out the total number of ways that the blue candles are together. And then from that, we're going to subtract the number of ways that you have blue together and red together. What is that going to give you? That is going to give you the number of ways in which the blue candles are together and the red candles are not together. Okay? So remember, the primary condition is, yes, we can do this by the fence post method. Okay, you can do this by the fence post method. Why can we do this using the fence post method? Because the number of red candles are 2. Because the number of red candles are 2, you can do this using the fence post method. So those of you who are wondering कि fence post method क्या है? No, it would not be possible if there were 3 colors. Okay? So I'll explain how the fence post method works. First, let's do it this way. Okay, so this is method number 1. All right, so if you know an alternative method, hold on. Let's first do it using this method, and then we will worry about the other method. All right, so let's start by making 11 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many blue candles do we have? 3 blue candles. So let's put them together in a box. So these blue candles are all together, and there's no need to consider the number of ways they can be arranged while they're together because they're all identical. Okay? Now, this will give us the number of ways the blue candles are together. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be 9 factorial divided by, now excluding the 3 blue candles, there are still 2 red candles that are identical, and there are still 6 green candles that are identical. So we're going to divide by 2 factorial and divide by 6 factorial. Okay, let's work this out. Let's see what we get. So this is 9 factorial minus 2 factorial into 6 factorial. So that's equal to 252. So guys, let me solve this question, then I'll take your questions. Okay. Now, so this is basically the total. Okay. Now, why can we not just take total irrespective of any condition? Because the condition is that all blue candles are together and the red candles are not together. So this is your primary condition. Okay. Your primary condition is that the blue candles are together. So this now becomes your total. Okay. So we're now doing total, which is the number of ways that the blue candles are together. And now we're going to find out the opposite of this, which means that the total number of ways the blue candles are together and the red are not together. Okay. So now, once again, let's make 1, 2, 3, 4, 5, 6, 7, 8, 9. कितनी है? 10, 11. 11 है ना? हाँ. Okay. अच्छा, अब हम निकालते हैं the number of ways that the blue candles are together and the red are together as well. So that when we subtract it from the total, we get the opposite. So here we have all the blue candles in a box. So that's blue, blue, blue. And here we have all the red candles in a box. Okay. Now, how many units do we have? We now have 1, 2, 3, 4, 5, 6, 7, 8. So we now have 8 units to arrange, so that's going to be 8 factorial. But do not forget that these 8 candles include 6 green candles that are identical, so we're going to do 8 factorial divided by 6 factorial. So 8 factorial divided by 6 factorial, that's equal to 56. Okay, so now let's do 252 minus 56. What's that equal to? 252 minus 56, that's equal to 196, and that is the correct answer. Okay, so I'll give you guys a summary, then we will look at the alternative method also. So the alternative, first let's have a summary of this. So notice that we have a primary condition. The primary condition is that the blue candles are together. So first you find out the number of ways the blue candles are together. That is your total. And that is blue candles in a box. So now we have 9 units to arrange, 9 factorial, divide by 2 factorial because there are 2 red candles that are identical. Also divide by 6 factorial because there are 6 green candles that are identical. अब हम निकालते हैं ये प्राइमरी कंडीशन अपनी जगह पे रहेगी. Okay, but first let's find out the opposite of this. Okay, and the opposite of this would be that the red candles are together. So how many ways can the red candles be together? So we put blue together, we put red together, that's 8 factorial divided by 6 factorial, which is 56. Now when we subtract, what do we get? We get the total number of ways the blue candles are together and the red are not together. Okay? Sir, if there were more than 2 red ones, then we can't do this. No, you can still do this. Yeah, we'll do the happiness question also. Don't worry about that. We'll do the happiness question also. Okay, don't worry about that. Achha, first let's have a look at the alternative method. The alternative method is known as the fence post method. Okay, now why do we call it the fence post method? Let's see. The fence post method. Okay, Achha, before I give you guys the fence post method, I'd like you guys to have a look at some important concepts. Okay. So first of all, please understand the difference between not all are together and no two are together. So we have 3 objects, A, B, and C. All are together. There you go. Okay, now obviously they can be together in many other ways, but this is what all together look like. Okay. No two are together. That means we have to make sure that all of them are separated. Okay. Not all are together means that 2 of them can still be together. If there are 3 objects and not all are together, that means 2 of them can still be together. Okay. Achha, we use something known as a fence post method. Now, what is a fence post method? Fence post method, this is what the fence post method is. The fence post method is used when we have to make sure that no 2 objects are together. It can be applied to any number of objects. Called fence post because the posts represent restricted items that can't be together, and the fence represents unrestricted items that can be arranged in any way. The number of posts, that is places for restricted items, will always be 1 more than the fences. Okay? Achha. अब जैसे कि for example, let's have a look at this question. The committee that is chosen consists of 4 men and 2 women. They queue up randomly in a line for refreshments. Find the probability that the women are not next to each other in a queue. Okay, so that means the 2 women, we have to make sure that they're separated. Now, because it's 2, we can always do total minus together. Okay, 2 may we can do total minus together. We can use the fence post method also. Have a look at this. Yeah. If you have 2 objects and you have to make sure they're not together, you can use the fence post method. You can do total minus together also. Okay. But if the question says no 2 are together and you have more than 2 objects, then you can only use the fence post method. You cannot use total minus together. Okay. But if the question says not all are together, that means some of them can still be together. Some of them can still be together. If there are 5 people and you have to make sure that not all are together, that means 4 of them can still be together, 3 of them can still be together, 2 of them can still be together. So that in that case, you cannot do fence post method, but you can do total minus together. Okay? So coming back to this example, if you have to make sure that the 2 women are separated, so first you will place the men. So that's 1, 2, 3, 4. There are 4 men. And these men can shuffle amongst themselves 4 factorial number of ways. Now, as far as the women are concerned, we have to make sure that we place them somewhere in between the men. So how many places do we have? If there are 4 men, that means we have 5 places for women. Okay, so we always have 1 more place than so basically this is your fence and this is your post. How many fences do we have? We have 4 fences, so that means we'll have 5 posts. So we will do 5p2 because there are 5 places where a woman can be placed and there are 2 women to place. So 5p2 into 4 factorial. Okay, now the same thing can be done over here. Why? Because there are 2 objects that cannot be together. So let's exclude the 2 from the total. How many are we left with? We're left with 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, from these 9 candles, we have to make sure that the blue ones are together. Okay, so how do you make sure that the blue ones are together? You'll put them in a box. That's it. So blue, blue, blue. Now, how many places do we have to place the red candles? So we have 1 place over here, 1 place over here. So that's 2, 3, 4, 5, 6, 7, 8. Okay, we have 8 different places to place the red candles. Okay, and how many red candles do we have? We have 2 red candles. So we'll do 8p2, but remember these red candles are all identical, so we're going to divide by 2 factorial. Okay, why are we dividing by 2 factorial? You will not divide by 2 factorial when you're dealing with people, but you will here because the candles are identical. Okay. And then what about the other units? We have 1, 2, 3, 4, 5, 6, 7. So we're going to do 7 factorial. And do not forget that from these 7 candles, okay, there are 6 green candles. So that means you will divide it by 6 factorial also. So let's work this out. 8p2 divided by 2 factorial into 7 factorial upon 6 factorial is just as good as 7. So this way you get the exact answer, which is 196. Okay. Why not total minus together? We've already done that. This is an alternative method. Okay, so we've already done that using that method. This is method 2. So this is an alternative method known as the fence post method. Okay, and why are we doing this? We're doing this because there are 2 red candles. If there were, let's suppose, 3 red candles, or सवाल बोलता कि not all are together, then we can't do that. Why 9 spaces again? We don't have 9 spaces. We have 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8p2. So how do you know if you use the total minus? Here it is. How do I know? Here it is. There you go. This is how I know. Yeah, I'll do the amalgamate question also. Don't worry, guys. The stream is still 8. We're going to solve plenty of questions. Okay? We're going to solve. Yeah, we can't use this method if there were 3 red and the question said, okay, not all are together. Okay, we could have done this if there were 3 and the question had said, no 2 are together. Okay? This way, when we use the fence post method, we make sure that no 2 are together, irrespective of the number, whether they're 2, 3, 4, 5. But the fence post method is to make sure that they're all separated. Okay? Okay, now. So, I meant the horizontal lines. The horizontal lines will still be 7, of course, because we're still counting blue. There are 3 blue, okay, and then the remaining 6 candles. So that's 9. Why do we have 9? Because from the 11, we have removed the 2 red. Okay, so from the 11, we have removed the 2 red. So first we place the ones that have no problem. That is the remaining 9 candles, and then we look at the red ones. Okay. All right. Now, अच्छा बेटा, what if को ज़रा hold करें अभी? ठीक है. We have plenty of questions. The night is still young, so we have plenty of questions to solve. So you'll find the answer to most of your what ifs. ठीक है. So take it easy, guys. So should I go study P3? I don't know, beta. That's up to you. It's your call, your wish. Why 6 factorial? You mean why divide by 6 factorial? Because there are 6 green ones. So we will divide by 6 factorial. Okay. So do you have any video where you explain normal distribution like within 5 to 10 minutes, like the main content you did for binomial? I did a recent stream on normal distribution in which, no, I did not explain the concept. Watch some of my old stream, but if you want to learn normal distribution, but you also want to learn it within 5 to 10 minutes, so I suggest you compromise somewhere and watch a lengthy video, okay? All right, question number 3. Find the number of different possible arrangements of the 9 letters in the word celestial. So that would be 9 factorial divided by, how many letters repeat? So that's 2 factorial. Okay, and then we also have 2 L's, so that's also 2 factorial, whatever this is equal to, let's work it out. 9 factorial divided by 2 factorial into 2 factorial, that's 90,720. Sir, can 4 not be together? Yeah, of course, that's possible, but I don't understand in what context you're asking. Part B. Find the number of different arrangements of the 9 letters in the word celestial in which the first letter is a C and the 5th letter is a T and the last letter is an E. All right. So that's very demanding of the question. 9 letters. So 1, 2, 3, 4, 5, 6, 7, 8, 9. ठीक हो गया. So the first letter is a C. The 5th letter is a T. So that's 1, 2, 3, 4, 5. So the 5th letter is a T. And the last letter, which is the 9th letter, is an E. Okay? Now, how many letters are we left with? We now have to arrange 1, 2, 3, 4, 5, 6. 6 factorial. Do we have to worry about any repetitions considering that we have dealt with 1 E already, considering that we have dealt with 1 C already, considering that we have dealt with 1 T already? Do we have to worry about any repetitions? Yep, we still have to worry about 2 L's. So that means we're going to divide by 2 factorial. What is that equal to? Let's work it out. 6 factorial divided by 2 factorial. That's equal to 360. Okay, now let's do part C. Find the probability that a randomly chosen arrangement of the 9 letters in the word celestial does not have the 2 E's together. Okay, which method do you guys want to use? The fence post method or the total minus together? Gap rule, I don't know what the gap rule is. I'm not too sure what the gap rule is. So total we already have, right? Total is 90,720. Fence post, okay, let's use the fence post method. All right, so notice that we have a total of 9 letters. Okay, and from the 9 letters, there are 2 E's. So let's ignore the 2 E's and let's start by making 7 blanks. Okay, so excluding the 2 E's, we're left with 7 letters. So that's 1, 2, 3, 4, 5, 6, 7. Okay. Now, how many places do we have for the 2 E's? We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have a total of 8 places to place the 2 E's. So what are we going to do? We're going to do 8p2. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8. We have 8 different places to place the 2 E's. So, and then we're going to divide by 2 factorial. Okay. And then do not forget about the remaining 7 letters. As far as the remaining 7 letters are concerned, we're going to multiply by 7 factorial. Acha. As far as the remaining 7 letters are concerned, what are the repetitions that we must take into account? So we've dealt with the 2 E's, so we don't have to worry about that. There are still 2 L's that can be repeated, so that means we're going to divide it by 2 factorial. Okay. Gap method, space method, okay, they're the same. All right, now. So 8p2 upon 2 factorial into 7 factorial divided by 2 factorial. So what do we get? We get 70,560. 70,560. Why divide by 2 factorial? Because there are 2 L's in the remaining 7 letters. That's why we're dividing by 2 factorial. Okay. I don't know which past paper is the aeroplane one. Let me know which one it is. Okay. I will include it. Don't worry. I will include it. And why are we dividing by 2 factorial over here? We're dividing by 2 factorial over here because of the 2 E's. Okay. So we have 70,560 divided by 90,270. But I've taken your request. I would really appreciate if you stop spamming now. Okay. So what do we get? We get 784 over 1003. No, wait a minute. 70560. Wait, मैंने कुछ division में गड़बड़ कर दी. 70560 divided by 90270. Oh, it's 90720. Oh. क्या बोलते हैं इसको? Parallax error. नहीं. There is a name for this error in accounting, correct? Parallax error तो physics में होता था. What is the name for this error? Transposition error, something like that? Doom solving. 7 over 9. Transposition, yeah, transposition error. Yes. It's transposition error. Okay, now. No. Doom solving. Okay, this is not. Yeah, this does classify as doom solving. It's definitely not ego solving. Ego solving is when you say you don't need a calculator, you can work it out mentally. Okay. Error of original entry. No, I'm pretty sure it's not error of original entry. Anyway. 5 letters are selected at random from the 9 letters in the word celestial. Alright, this should be fun. अब आ गई है probability and probability in combination. Find the number of different selections if the 5 letters include at least one E and at most one L. Alright. How many marks? 3 marks. Okay. So we're talking about 5 letters. So start by making 5 blanks. 1, 2, 3, 4, 5. Now, at least one E, that means the number of E's must be greater than or equal to 1. And at most one L, that means the number of L's must be lesser than or equal to 1. Okay? Alright. So let's begin by selecting one of both. One E and one L. Okay. Now here's the word celestial. ठीक है. अच्छा, अब एक काम करते हैं. Since we have to make sure that we're only selecting one E and one L, and we don't end up selecting any more, so let's cross out the E's. Okay, let's cross out the L's. We have to make sure that we only select one E and one L. Okay, so if I've already selected one E and one L, that means I still have to select 3 more letters. Okay, I still have to select 3 more letters. Now, how many letters do I have left to select the remaining 3 letters? I have 1, 2, 3, 4, 5. So that means from the 5 letters, I'm going to select 3 letters. What is that equal to? 5C3, that's equal to 10. Okay. Now, is this it? Is this the only way that I can select at least one E and at most 2 L's? No. Obviously, there is more. अच्छा, एक काम करते हैं. Let's keep the number of L's locked at 1. Let's increase the number of E's. So let's see how many ways we can select 2 E's and 1 L. So 2 E's and 1 L means that we've already selected 3. Now we have to worry about selecting how many? We only have to worry about selecting 2. So that's going to be 5C2, which is also equal to 10. Okay? Now, can we increase the number of E's to 3? No, we cannot. But what we can do is we can dial it down. We can dial down the number of L's. We can go with 1 E and 0 L, because the question says at most 1 L, so you can have 1 or less than 1, or you can have 2 E's and 0 L's. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now, if you select 1 E, that means now you still have 5 letters to choose from, but now you only have to choose 4, so that's going to be 5C4. 5C4, what's that equal to? That's equal to 5. If you've already selected 2 E's, that means now you still have 5 letters to choose from, and you now only have to select 3. So 5C3, that's equal to 10. So 10 plus 10 plus 10, that's 30. 30 plus 5, that's equal to 35. Achha, those of you who are saying, okay, when do we consider repetitions as well? You do that when it's probability. Okay, this is not probability. So you're not going to consider repetitions. When it's probability, that is when you consider repetitions. Okay, so the final answer is equals to what? The final answer is equals to 35. Okay. Okay, and I'm afraid there is no other method to solve this question. This is the only method. Okay, so my advice, might as well learn how to solve this method. Okay, now, no, there is no other method. Okay, however, if you do find out, Mariam, any other method, then please let me know. So in part C, where did the denominator come from? In part C, since it's probability, so with the total is the answer to the first part, total without any restrictions. Okay. We'll do probability plus combinations as well. Don't worry about that. We'll do probability plus combinations as well. Okay. चलो पहले ये करते हैं. Let's do question number 4. So the question said at most 1L, you can't use 2L. So I didn't use 2L. Where did I use 2Ls? Where do you see 2Ls? Okay, question number 4. Question 4 says, find the number of different arrangements that can be made from the 9 letters of the word jewelry in which the 3 E's are together and the 2 L's are together. All right. Achha beta, 20-25 questions I will do towards the very end. So guys, just be patient. I'll solve plenty of questions, okay? The stream is till 8. What do you think I'm going to do till 8? We're not going to chit chat till 8, right? So we're going to solve plenty of questions. So hold it. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So let's put the 3 E's in a box. Here we have the 3 E's in a box. So E, E, E. And the 2 L's are together. So let's put the 2 L's in a box. So we have the L and the L. Theek ho gaya? Okay. Now, any other repetition that we have to worry about? I don't think so. 1, 2, 3, 4, 5, 6. So 6 factorial divided by, so other than the 3 E's and the 2 L's, is there any other letter that's repeating? No. So 6 factorial, no need to divide by anything. 6 factorial is going to be the final answer, which is equal to what? Which is equal to 720. All right. Now, find the number of different arrangements that can be made from the 9 letters of the word jewelry in which the 2 L's are not next to each other. Okay, so what method can we use over here? We can use both. We can do total minus together, or we can use the fence post method. I'm going to go with the fence post method. Okay, so it's going to be good practice of this method. So notice that there are 9 letters. Of the 9 letters, there are 2 that can't be together. Okay, so won't it be 6 factorial divided by 2 factorial into 3 factorial? No. Why would you divide it by anything? Because the 3 E's are together and the 2 L's are together. So you're not going to divide it by anything. It's just going to be 6 factorial. That's it. Mariam, abhi aap kuch bol rahi hai, abhi aap kuch bol rahi hai. Make up your mind, beta. Okay, now. So 1, 2, 3, 4, 5, 6, 7. Why 7? Because there are 9 letters. Okay, there are 9 letters. So, and from the 9 letters, the 2 L's are not next to each other. So what we're going to do is we're going to exclude the 2 L's and we're going to make space for the remaining 7. Now, where can we place the L's? We can place the L's in 8 different places. 1, 2, 3, 4, 5, 6, 7, 8. So we can place the L's in 8 different places and there are 2 of them. So that's 8p2. And because they're identical, we're going to divide by 2 factorial. Okay? And then as far as the remaining 7 letters are concerned, that's going to be 7 factorial. Okay, so as far as the remaining 7 letters are concerned, 1, 2, 3, 4, 5, 6, 7, that's going to be 7 factorial. But watch out, in these 7 letters, there are 3 E's, so you also have to divide by 3 factorial. Okay, so you also have to divide by 3 factorial. So work this out. What do you get? Here's what you get. You get 8p2 divided by 2 into 7 factorial divided by 3 factorial. So that's equal to 23,520. So let me complete this question, then I'll have a look at your questions. Okay, so 23,520 is the answer. All right, now, what is the problem? So can I do 8c2 instead of 8p2 upon 2 factorial? Yes, you can. As long as it's clear to you why you're doing what you're doing, you can do that. Okay. Can we do it without p? You can do total minus together. Yes, you can. You can do total minus together. Total would be just the total. Minus together would be the number of ways that the two L's are together. You can do it that way also. Okay, so I'll do it that way also. I'll do it total minus together method. Same thing. So total we've already worked out. No, wait, we haven't worked out the total. Okay, so let's find out the total. So as far as the total is concerned, there are 9 letters, so 9 factorial divided by 3 factorial into 2 factorial. Okay, what's that equal to? 9 factorial divided by 3 factorial into 2 factorial, that is equal to, so isn't without arrangement minus 2 is together easier? If you find that way easier, then stick to it. I find the fence post method easier. Okay. All right, so this is the total. Now let's find out the number of ways they are together. So the number of ways they're together, first let's start by making 9 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we have to make sure that the two L's are next to each other. So let's put them in a box. So here's a box where we will place the two L's. Now how many units do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. So this will now be 8 factorial. And don't forget that other than the two L's, there are 3 E's that are repeating. So we'll divide by 3 factorial also. Okay, so we'll do 8 factorial divided by 3 factorial. What's that equal to? 8 factorial divided by 3 factorial. That's equal to 6,720. So now what you have to do is you have to find out the number of total without any restrictions minus the number of ways the two L's are together. That way you will have the number of ways that the two L's are not together, which is once again 23,520. Okay, अब यही दो method हैं. I'm not sure if there is a third method, but if there is, it's best that you stick to any one of these two. So how do we know when to use P or C? Because P is for arrangement, C is for selection. Okay, if you want to arrange, you're going to use permutation. If you want to select, if you want to choose, then you're going to use combination. Okay, so if the question was about two consonants not being next to each other, does the fence post method work? Because we can't place the vowels to the leftmost or the rightmost place, right? I think I know the question that you're talking about. I'll see if I can include that question in the stream. Okay, now let's do this question and then we'll do some recent questions. If you're making groups, again, you're selecting, right? You're selecting people for a group. So that is permutation, that is combination. In a music competition, there are 8 pianists, 4 guitarists, and 6 violinists. 7 of these musicians will be selected to go through the final. Okay. How many different selections of the 7 finalists can be made if there must be at least 2 pianists, at least 1 guitarist, and no more violinists than guitarist? All right, this should be fun. I've noticed that how many pianists do you have? You have 8 pianists. How many guitarists do you have? You have 4 guitarists. How many violinists do you have? You have 6 violinists. All right. There must be at least 2 pianists, at least 1 guitarist, and more violinists than guitarists. वाह, आधे से ज़्यादा बंदे को तो यही पढ़ के ही चक्कर आ जाए. चलें, कोई बात नहीं. So the number of pianists must be greater than or equal to 2. All right. The number of guitarists must be greater than or equal to 1. Okay. And the number of violinists must be greater than the number of guitarists. Okay. Now, let's list all the possible ways this can happen. So we can have 2 pianists, 1 guitarist, and remember the total must be equal to 7. Okay, so the total number of people that you select must be equal to 7. So we can have 2 pianists, 1 guitarist, and in order to complete the team of 7, we'll have to select 4 violinists. That is correct. Okay. So then you have 2 pianists. We can have 2 guitarists. That's acceptable. But the number of violinists must be more. So that means we have to take 3. अच्छा अब आप लोग साथ में ये करो, इसके number of ways भी निकालते रहो. ठीक है, like for example, this will be 8C2 into 4C1 into 6C4. Okay, so work this out on the side. And this will be 8C2 into 4C2 into 6C3. All right, what else can be done? Let's increase the number of pianists by 3. And let's keep the number of guitarists at 1, which means that we gotta have more violinists than guitarists, and we have to make sure that the total is 7, so that's 3. ठीक है, और कुछ हो सकता है? Let's increase the pianists by 1. Let's take 4, and I can take 1 guitarist, and if I take 1 guitarist, I have to take 2. 5, 1, 1 तो नहीं हो सकता. This is not possible because the number of violinists must be greater than the number of guitarists. अच्छा, और can we do 4, 2, 1? No. So that's it. That's it. ठीक है? So we can't do this. We can't do this. And that's it. Now the order in which you make these possible combinations, there is no right or wrong order. Just make sure that you consider all possibilities. Okay? Just make sure you consider all possibilities. That's what matters. So you have 8C3 into 4C1 into 6C3. Then you have 8C4 into 4C1 into 6C2. Okay, so let's work this out. 8C2 into 4C1 into 6C4. That's equal to 1680. Then 8C2 into 4C2 into 6C3. That's equal to 3360. Oh, Ira, that's very nice. Then we have 4480. Thank you. Then we have 4200. All right, Ira, I'm counting on you. So I hope you've given me the correct answers. अच्छा, इनको ऐड कर लेते हैं. 1680 plus 3360 plus 4480 plus 4200. That is equal to 13,720. There we go. That's it. Acha. Which iPad do I use? Why does it matter which iPad do I use? Okay. I'm not going to tell you. All right. Where am I going for my vacations? I haven't decided yet. Let's see. Sir, do you recommend doing PNC in the start of the paper because it takes less working and more brain? No, I do not recommend that you do PNC at the start. I recommend you do it towards the end. So drawing the boxes and showing possible arrangements through lines can be done with pencil. No. Do it using a pen only. Discrete random variable. I've already done discrete random variable. Time management tips. Time management tips towards the end. But why didn't we increase the number of guitarists? But why do you want to increase the number of guitarists? I don't get it. You want to increase the number of guitarists? Go ahead. If you increase the number of guitarists, you'll have to make sure that the number of violinists are more than the number of guitarists. And if you do that, you will exceed the total. The total is 7. Okay? So Mariam, instead of arguing, I would suggest that you write down all the possible combinations and see if it's possible. Why didn't I make it 4? But if I select 4 guitarists, then I'll have to select at least 5 violinists. Does that make sense? I think you're not reading the question, Mariam. Why would I select 4 guitarists? Pehli baat to ye, if I select 4 guitarists and if I select 2 pianists, which I have to at least, so that's 4 plus 2, that's 6. That means I can only select 1 violinist. And that's not possible. The number of violinists must be more than the number of guitarists. Okay? So remember what I said earlier? Half my job is teaching, the other half is just reading the question again and again for you guys. Achha, koi baat nahi. Achha, now let's do some difficult questions. Kya khayal hai? Let's increase the difficulty level a little. अच्छा crocodile भी कर लेंगे, पहले करते हैं question 24. Okay, so this is the question that you're talking about. 2010. No, I'm not solving 2010 past papers. Okay, so I'm only going to be solving 2020 onwards. Okay. Find the number of different arrangements of the 9 letters in the word activated. Acha chale Mariam, no problem. Okay, but remember, in the exam, make sure that you read the question as carefully as possible. Okay. So yeah, 9 factorial. Any repetitions that we have to worry about? Are there any repetitions? Activated. A repeat हो रहा है 2 दफ़ा. और क्या आ रहा है? E 1 दफ़ा आ रहा है. Activated. T 2 दफ़ा आ रहा है. So that's 2 factorial into 2 factorial. And I guess that's it. That's it. Any other repetition to worry about? No. So this is equal to, I think we did a question with similar values. So yeah, 90,000 aega. Divide by 2. Yeah, 90,720. Okay, now find the number of different arrangements. So once again, arrangements, that means permutation, of the 9 letters in the word activated in which there are at least 5 letters between the 2 A's. All right, so 5 letters between the 2 A's. 5 letters between the 2 A's ka matlab, let's first start by making 9 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 letters between the 2 A's. So let's place an A. Let's leave 5 blanks. 1, 2, 3, 4, 5. And then let's place an A again. Okay, now. So what about the remaining letters? So we have 7 letters that we can still shuffle. So that would be 7 factorial. ठीक है. And then don't forget that in these 7 letters there are still 2 T's that are repeating, so divide by 2 factorial. And here's the thing, as far as these 2 A's are concerned, they can be placed in 3 different places while still having 5 letters in between. So that's 1, 2 and 3. Okay, so as far as these 2 A's are concerned, with 5 letters in between, can be placed in 3 different places. So that's 1, 2 and 3. Okay, so I repeat, 1, 2, 3. So you can place these A's in 3 different places while still having 3 letters or 5 letters in between. So we multiplied by 3. Okay. Achha, notice that the question said that there are at least 5 letters. What does that mean, at least 5 letters? 7 factorial divided by 2 factorial into 3. At least का क्या मतलब है? At least का मतलब है कि you can have more than 5 also. Okay, at least 5 means that you can have greater than or equal to 5. Okay, and if it's greater than or equal to 5, that means it's possible to have 5, it's possible to have 6, and not more than that. It's not possible to have 7 letters in between. Why? Because the total is 9. So it's not possible that you have 7 letters in between. Yeah, it's not possible. Okay, so this is with 5 letters in between. Now let's try with 6 letters in between. 1, 2, 3, 4, 5, 6, 7, 8. Acha, wait, 7 भी possible hai. Yeah, 7 भी तो possible hai. Of course, there are 9 letters, right? So 7 भी possible hai. Yeah, so it's possible to have 7 also. So let's look at how many ways we can have 2 A's with 6 letters in between. So that's 1, 2, 3, 4, 5, 6. And there we go. Okay. So now we have how many letters to worry about? We have 1, 2, 3, 4, 5, 6. 6 letters to worry about. So that's 6 factorial divided by 2 factorial because of the 2 T's. And these 2 A's with 6 letters in between them can be placed in 2 different places. Okay, so these 2 A's with 6 letters in between them can be placed in 2 different places. So we're going to multiply it by 2. So what's that equal to? Let's work it out. 6 factorial. That's equal to 720. Acha, the alternative method, let's explore that in a minute. Now let's look at 1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, you're right. You're right. You're right. You're right. I made one less blank. So that's 7. Okay, thank you. Now what about the 2's with 7 letters in between them? So the 2's with 7 letters in between them can only happen one way. Can only happen by 7 factorial divided by 2 factorial. That's it. Okay, so 7 factorial divided by 2 factorial, that's equal to 2520. Okay, now let's find out the total. The total would be 7560 plus 5040 plus 2520. So 2520 plus 5040 plus 7560, that's equal to 15,120. This is the total right here. Okay. Acha, अब you guys are saying that there is an alternative method also. अच्छा, alternative method इसका क्या हो सकता है? Your A position is wrong? Is it? 1, 2, 3, 4, 5, 6, 7, 8. अच्छा, ठीक है. I get it. ठहरो. 1, 2, 3, 4, 5, 6, 7, 8, 9. सही तो है? What's wrong? किसकी बात करें आप लोग? 1, 1, 2, 3. एक second, 1. Oh, okay, I get it. Okay, I get it. ठीक है, now we have 6 letters in between them. ठीक है, सही है. 7 factorial divided by 2 factorial into 2. ठीक है, सही है. Alright, अच्छा, let's look at the alternative method. ऊपर वाले में तो सही है ना? 1, 2, 3, 4, 5. हाँ, सही है. अच्छा, इसका ऑल्टरनेटिव मेथड क्या हो सकता है, वो भी ज़रा एक्सप्लोर कर लेते हैं. लेट मी थिंक. ऑल्टरनेटिव मेथड ये हो सकता है कि यू कुड डू 7 है ना, 7p5. Other than the 2a's, you can do 7p5. I'm not really sure if that's going to be a shortcut. I'm not really sure if that is going to be a shortcut. ठीक है. Yeah, I know 7p5 into 3 factorial upon 2 factorial, but इसमें भी आपको cases तो उतने ही consider करने पड़ेंगे ना. It's not that it's going to be a shortcut. You have to consider 3 cases now, you'll have to consider 3 cases then. So it's really not that it's going to be a shortcut. I don't think it's going to be a shortcut. The number of cases will remain the same. Okay. So I don't think so. So let's do part C. Part C is actually the reason why I really want to solve this question. Why? Because there is probability. Okay. So part C is the reason why I want to solve this question, because there is probability. So let's rewrite the word again. Activated. So will I find M1 easier if I take A-level physics? I'm horrible in S1. Yes, you will. I think you will be familiar with the basics. Okay. So find the probability that this. First of all, notice that it says 5 letters are selected at random from the 9 letters. So the first thing you want to do is you want to do 9C5. Okay, now what is 9C5 equal to? Let's see, 9C5, that's equal to 126. Okay, so this way we can guarantee some marks, I think. Yeah, total अगर हम निकाल लेते हैं तो 1 mark तो I think guarantee हमारा हो जाएगा या नहीं. No, if you just calculate the total, there is no guarantee, but let's at least start working out the cases one by one. Achha, notice the question says the selection does not contain more T's than A's. Okay, so the selection does not contain more T's than A's. Okay. Now make sure that you select 5 letters. Now let's list all the possible combinations. Does not contain more T's than A's. So how about we take 0 of both? How about we take 0 T's? Okay, we take 0A and 0T. So yeah, we can do that, right? The question said does not contain more T's than A's. That means they can be equal. Okay. So if we have to make sure that no A is selected, we'll cross them out. If we have to make sure that no T is selected, we'll cross them out. So now we're down to how many letters? We're down to 1, 2, 3, 4, 5, and we have to select 5. So that's just going to be 5C5. And what's that equal to? That's equal to 1. Yeah, I'll do the alligator one also. No worries. Okay. Now, what about 1A and 0T? Can we do that? 1A and 0T? Yes, we can. Remember, the condition is that does not contain more T's than A's. Does not contain more T's than A's. Okay? So, 1A and 0T. 1, 2, 3, 4, 5. So, if I'm selecting 1A and I'm not selecting any T, what does that mean? How many ways can I select 1A? Notice that there are 2 A's to select from. That means we're going to do 2C1. So why are we doing 2C1? We did not do that earlier. We're doing it because of probability. Okay, we're doing it because of probability. Whenever there is, so let's park this over here. Okay. Whenever there is probability, what we do is the total letters includes repetition. Okay. Whenever there is probability in the total, the repetition is included. Okay. Or you can say repetition is to be considered as different. Okay. In fact, ये लिख लेते हैं. Repetition is to be considered as different. Now notice that we have to select. Notice that we have to select how many A's? We have to select 1A. And how many A's do we have to choose from? We have 2 A's to choose from. Okay. So if we have 2 A's to choose from, what are we going to do? And we have to choose one. We're going to do 2C1. So even though there is repetition, but we're treating them as different. Okay. So that is why we will do 2C1. And this only happens when there is probability. Okay, this only happens when there is probability. If let's say the question is asking for the number of ways and it does not include probability, then you're not going to consider that. Okay? Okay, now. Just a minute. Okay, now. 1A and 0T. So that's 2C1 for the 2 A's to choose from and 1A to choose. Now how many letters are we left with? We're now left with 5 letters and we have to choose how many? We have to choose 4 of them. So that's 5C4. So 5C4 is 5. 5 times 2, what's that equal to? That's equal to 10. If probability wasn't, then you will just do it the normal way. Then you will not include the A in your total letters. Okay, we just did a question. If let's say the question did not include probability, then you will not include A, the other A in your total. We just did a question. Yeah, here. So notice that when we've already selected an E, okay, we crossed out the other E. And to find out how many ways that we can select one E, we did not do 2C1. Why did we not do 2C1? Why? Because this is not probability. Okay, whenever there is probability, that is when we do. That is when we treat repetition as different. Okay. Okay, so where were we? Acha beta, let's complete this question. Okay, then we'll take a break. All right, let's complete this question, then we'll take a break. So Take it easy. All right, now let's increase the number of A's. So how about we select 2 A's and we still don't select a T? Why times 2? Where did I multiply by times 2? I just did 2C1. 2C1 because there are 2 A's to choose from. So where did I do times 2? I just did 2C1. 2C1 because there are 2 A's to choose from and we're selecting 1. And why are we doing it this way this time? Because this is probability. Alright, so 1, 2, 3, 4, 5. अच्छा भाई काम करते हैं. Let's pause and let's find out all the possible ways that this can happen. So we can increase the number of T's. So we can go from 2A to 1T. Okay. We can also do 2A and 2T. The condition is that the number of T's must not be more than the number of A's. And we can also do 1A and 1T. Okay. Any other possibility? No, we only have 2 A's to choose from, so we can't go to 3 A's. All right. See, it's a 5-mark question, so it makes sense. It's a 5-mark question, so it makes sense. All right, so if I'm selecting 2 A's and 0 T's, that means I'm going to do 2C2 multiplied by 5C3. Okay, so 2C2 for the 2 A's, and then excluding the A's, excluding the T's, we still have 5 letters to choose from, and we have to choose 3, so that's equal to 10 also. Okay, let's drag this total away. Let's place it here. Okay, now let's look at how many ways you can have 2 A's and 1 T. So 2 A's and 1 T means 2C2, and there are 2 T's to choose from, so that is going to be 2C1, and now we're down to 5 letters and we still have to select 2, so that's going to be 5C2. Okay, so 2C2 into 2C1 into 5C2, that's equal to 20. All right, then 2 A's and 2 T. 2 A's and 2 T means 2C2 into 2C2 into 5C1, which is simply equal to 5. Then finally 1A and 1T. So how many ways can you select 1A? That's 2C1. How many ways can you select 1T? That's also going to be 2C1. Now you're down to 5 letters and you still have to select 3 more, so that's going to be 5C3. So 5C3 into 2, that's equal to 40. So here we have 40 plus 5 plus 20 plus 10 plus 10, that's equal to 85. So this is what? This is your favorable outcome. Now what are we going to divide this by? We're going to divide this by the total. Okay. Oh, 86 भी तो है. लो, ये उस बेचारे एक को भूल गया मैं. ठीक है. The very first possibility उसको भूल गए. 86 है. ठीक है. So there's this, there's this, there's this. There are altogether 6 ways. 6 and 7. 1, 2, 3, 4, 5, 6, 7. So there are 7 ways. Yeah. So here we are, we have 86, that's the favorable, divided by the total, which is 126. So 86 divided by 126, what's that equal to? That's equal to 43 upon 63. ठीक है? अच्छा, अब let's take a small break. सही है? And then is there another part to it? No. Let's take a small break. फिर हम break के बाद inshallah we will solve some recent questions. Sir, I have only been doing topical. Should I do yearlies now? बेटा अभी भी क्या जल्दी है, आप आराम से समर ब्रेक में करना ना. अभी पहले एग्जाम से फारिग हो जाओ, फिर समर ब्रेक में आराम से बैठ के ईयरली पास पेपर्स करना. ठीक है? Of course बेटा, you need to do yearly past papers. What about all the other exams? What about P1 and M1? I don't know if you appeared for P1, but you did you not solve any yearly topical yearly past papers of P1? All right, so let's take a break. Let's take a namaz break and then we will resume. Okay. Okay, guys. So, welcome back. Yeah, tomorrow I am doing a syllabus run through. Don't worry. So I lose 1-2 marks for stats 1 when doing paper. I lose about 7 marks in my pure exam. Am I in a good place? If you're losing 1-2 marks in S1, that's not bad. And even if you're losing 7 marks in P1, that's pretty good actually. Also, do you remember I was in your last year ad math class? Sana. I am afraid I don't, but wait, I do remember Asana from last year. I think I do. I'm not too sure, but I think I do. Okay, now. Yeah, so now let's do some questions from recent years. Okay, and I'll include the happiness question also, don't worry about that. Let's do some questions from recent years, starting with this one. This is from May-June 2025, paper 5, variant 3. Okay. May-June 2025. Oh, this is that question. Yeah, I'll do the crocodile question also. Don't worry. I'll do the crocodile question also. You're welcome. So how do you feel about Mercedes dominance this year? The rules are changing, so the other teams are catching up. Let's see. Let's see what happens. Too soon to say anything. Okay, just making sure I have the right question. So the first part says, question number 7 of May-June 2025, paper 5, variant 3. Let's see what it says. So let's see what it says. A set of friends consists of 7 men and 4 women. 3 of the men are brothers, Ali, Ben, and Charlie, so A, B, and C. Find the number of different arrangements of the 7 men in a line in which Ali and Ben do not stand next to each other. Okay, so we have to make sure that 2 people don't stand next to each other. You can do total minus together, or you can use the fence post method. Both of them is possible. So we're talking about 7 men. So let's exclude Ali and Ben. So that means we're now dealing with 5 men. 1, 2, 3, 4, 5. So they can stand any way possible. So that would be 5 factorial. Okay, as far as the 5 men are concerned. 1, 2, 3, 4, 5. But there are 2 men, Ali and Ben, who we have to make sure do not stand next to each other. So what we'll do is we will see how many spaces they have. So they have 6 spaces to stand, and there are 2 of them, so that's 6p2. Okay. Mutually exclusive and independent is part of the syllabus, but yes, they're not that frequently tested. I've done some streams on, I've covered some questions in the probability stream, so you can check that out. So this is equal to 3600. 3 easy marks. All right, part B. Find the number of different arrangements of the 7 men and 4 women in a line in which all the men stand together and all the women stand together. All right, so let's start by making 11 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's put the 3, 4, 5, 6. No, wait, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So let's put the 7 women in a box. Oh, sorry, 7 men in a box and the 4 women in a box. Here we go. Now they can shuffle amongst themselves, so that would be 7 factorial. The 4 women can shuffle amongst themselves, so that would be 4 factorial. 7 factorial into 4 factorial multiplied by 2 factorial. Okay, why did I do 6p2? Because there are 6 different places where Ali and Ben could stand, and there are 2 of them. Ali and Ben are 2 people, and they can stand in 6 different places, so that's why we do 6p2. So 7 factorial into 4 factorial into 2, what's that equal to? That's equal to 241,920. 2c1, why would you do 2c1? Part A में women को count नहीं करेंगे because we're dealing, बेटा सवाल तो पढ़ो ना. We're talking about the arrangements of the 7 men. So why would you consider any women to begin with? Okay. And 2c1, I'm not sure why will we do 2. Why you're saying 2c1? I'm not sure I understand that. All right, now then comes part C. Part C says, in how many ways can the 7 men be divided into a group of 6, a group of 3, and a group of 2 if there are no restrictions? All right, so altogether we have 11 people. Total equals to 11. ठीक है. अच्छा, first we divide them into a group of 6. So that's 11C6. Now 11C6 means that 6 people have already been placed in a group. Now we're down to how many people? Now we're down to 5 people. So that's 5 people. Achha, why are we doing C over here? Because we're dealing with groups. Okay, we're dealing with groups. Groups means that we are going to use combination. No, like 2 men selected in the places. This is not about selection, it's about arrangement. That's why we can't do that. Okay, so 11C6 into 5C3, and now we're down to 2 people, and we have to make a group of 2, so that's 2C2. Okay, so 11C6 into 5C3 into 2C2, that's equal to 4,620. Okay. So for the questions that include probability with permutations and combinations, do we have to consider? Yeah, in questions where you have probability, and it usually happens in combinations. So in combinations, repetition is to be treated as different letters. Okay, letters that are repeating are to be treated as different letters. Okay, now, अच्छा देखो, अब पूरे part में कोई चीज़ मुश्किल नहीं थी. So permutation combination is challenging, but majority of the times there's only one part which is challenging, and I think that's this part that we're about to solve. Okay, so far all the questions were straightforward. The 7 men and 4 women are divided at random into a group of 6, 3, and 2. We just did that. Okay. Find the probability that Ali, Ben, and Charlie are all in the same group. All right. Now there's a group of 6. 1, 2, 3, 4, 5, 6. There's a group of 3, 1, 2, 3, and there's a group of 2. Now, if you think about it, Ali and Ben can possibly be in a group of 6. Okay, why will we not divide? Because we're dealing with people, we're not dealing with objects. People are unique. Objects can be identical. Okay, so it's possible for Ali and Ben to be in a group of 6. It's, Ali, Ben, and Charlie. It's possible for Ali, Ben, and Charlie to be in a group of 3, but it's not possible for them to be in a group of 2. Because we have to make sure that all 3 of them are in the same group. So it's possible that Ali, Ben, and Charlie are in a group of 6. It's possible that Ali, Ben, and Charlie are in a group of 3, but it's not possible for them to be in a group of 2. Achha, अब let's look at how many ways can these 11 people be divided into groups of 6, 3, and 2 while making sure that Ali, Ben, and Charlie are in a group of 6. Achha, first of all, let's exclude these 3 people. So that means now we're down to 8 people. Okay, now we're down to 8 people. So here's what we're going to do. We're going to do 8C3 to select the remaining 3 members of the group of 6. Then we're going to do 5C3 to select 3 members from the remaining 5. Then we're going to do 2C2. Okay. अच्छा, they're brothers. I'm not sure if they're brothers. ठीक है, खैर हो गई, इतनी बारीकियों में नहीं जाते. 8C3, 5C3 into 2C2. Okay, so let's see what that is equal to. 8C3 into 5C3 into 2C2, that's equal to 560. Okay, so you can see Ali, Ben, and Charlie are in a group of 6. Okay. Now, what if they are in a group of 3? So this means that now we have to select 6 people from 8. So that would be 8C6. And then after that, we're down to 2 people and we have to select them for a group of 2. So that's 2C2. They are brothers. Okay, they are brothers. ठीक है. अब वो कैसे brothers हैं? That's not our concern. 8C6 into 2C2. Okay, so 8C6 into 2C2. Yeah, maybe Ali is adopted. Or maybe Ben and Charlie are adopted. Why would you make Ali adopted? Maybe Ben and Charlie are adopted. So we have 588. Okay? Achha, bear in mind that we have to find out the probability. So this is the favorable. Okay? So 588 divided by the total. What is that equal to? Total is 4620. So total is 4620. Let's divide this by 4620. So what's that equal to? That's equal to 7 upon 55. Is it possible for Ali, Ben and Charlie to be in a group of 2? No, that's not possible. Okay. This was easy, sir. How is it hard? I never said this is hard. Is there another method? I don't know. I don't think so. I mean, it's already pretty straightforward. I don't think there's any other method. अच्छा, अब इस पे आ जाते हैं. Amalgamate. 2. But that still doesn't answer my question. अच्छा खैर. Let's solve this question. Find the number of different ways in which the 10 letters of the word amalgamate can be arranged so that there is an M at the beginning, an M at the end, and no A's are together. Okay, can we do this by total minus together? Sir, if you are choosing something for 4 spaces and we have 2 C's and 1 has to be in those 4, do we do 2C1? If we have 4 spaces, no, you do, okay, here's what you do. You do 4P2 divide by 2 factorial. Okay, 4P2 because there are 4 spaces, 4P2 because there are 2 C's, divided by 2 factorial because the 2 C's are identical. Can we do total minus together? No. We can't do total minus together. Why? Because, no. Notice the question says no A's are together. The question does not say that not all A's are together. Okay, there's a difference between no A's are together. No A's are together is not the same as no A's are together is not equal to, okay, I'll put a cross across it in a minute. Not all A's are together. Okay. In this case, why is it that it's not the same in this case? Because there are 3 A's. Why? Because the question is why, the answer is there are 4 A's. 4, 1, 2, 3, 4. Okay, because there are 4 A's. Alright? So there's a difference between no A's are together and not all A's are together when the number of letters that we're talking about are more than 2. Okay? Okay, now. So, अच्छा wait. हानिया, आपका सवाल क्या था? आपका सवाल था कि we're choosing. So let me see. Sorry, I don't get when to do total minus together. Okay, Zakaria, the answer to your question is this right here. Okay, you take a look at this while I'm answering Hania's question. Sir, if you are choosing something for 4 spaces and we have 2 C's. But why would you be in a situation like that? Isme to we'll have to figure it out manually, Hania. There is no way to use combination here. Okay? So you have to tell me exactly, you have to point me towards a question for me to be able to answer this question. Here you go. Okay. All right. Now let's solve this question. So notice the condition is that there is an M at the beginning and there is an M at the end and no A's are together. So altogether there are 10 letters. So first of all, from the 10 letters, let's remove the 4 A's. So how many letters are we down to? We're down to 6. 1, 2, 3, 4, 5, 6. So from the 10 letters, I have removed how many A's? Yeah, I'll share this PDF. Did I not share this already? Okay, I'll share this PDF. I'll add this PDF in the same folder as these questions that I'm solving, which you will find in the link in description. Okay, now बेटा एरोप्लेन का मुझे ईयर बताओ. Tell me the year and paper. All right, now, so we have to make sure that there is an M at each end. Okay? Okay, now, where can I place the 4 A's? Can I place the 4 A's here? Tell me if what I'm doing is correct. 1, 2, 3, 4, 5, 6, 7. Is this correct? Is this correct? Yes or no? No. Why? Because we can't consider this option for an A and we can't consider this option for an A. Okay? We can't consider these two options for an A. Why? Because we have to make sure that the M's remain untouched. Okay, we have to make sure that the first letter is an M and the last letter is an M. Okay? So that means altogether, how many places do we have for the 4 A's? We have 1, 2, 3, 4, 5. We have 5 places. So this is going to be 5p4, but bear in mind that there are 4 A's, so that means all 4 of them are identical. And how many spaces are we left with? We're left with 4 spaces or 4 letters to shuffle, so we're going to multiply it by 4 factorial. So altogether, we're left with 5p4, which is equal to what? Which is equal to 120. That's it. ठीक हो गया? Okay, now, find the number of different ways in which 10 of the letters in the word amalgamate can be arranged with exactly 3 letters between the two M's. Okay, with exactly 3 letters between the two M's. So again, very repetitive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Overview. Okay, I'll just do a quick overview. So notice that you have a total of 10 letters, of which 4 of them are A's, and we have to make sure that no A's are together. So first we remove those 4 A's from the 10 letters. Now we're down to 6, so we make 6 blanks. We have to make sure that the M is the first and the last letter, so that means in between we can place the 4 A's. So altogether we have 5 different places to place the 4 A's. So we do 5p4, but because they're all A's, so divide by 4 factorial, and then we multiply it by 4 factorial because there are 4 letters that we still have to shuffle, and they can be shuffled 4 factorial number of A's. Okay? Okay, now, so what's the condition over here? We have to make sure that there are exactly 3 letters between the two M's. There we go. Okay. So other than the two M's, how many letters are we left with? We're left with 8 letters. So that means these 8 letters can be shuffled, can be arranged 8 factorial number of ways, and then we're going to divide it by 4 factorial. Now these two M's with 3 letters in between can be placed here, can be placed here. Okay, so count with me. 1, 2, 3, 4, 5, 6. So these 4 letters, these 2 M's with 3 letters in between can be in 1, 2, 3, 4, 5, 6 in 6 different places. Okay? So basically this is what we can do. We can place an M here, 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 and we can place an M here, and then finally we can place an M here and then leave 3 spaces. So we can place an M here, and then finally we can place an M here and then here. So altogether there's 1, 2, 3, 4, 5, 6. 6 different places. Okay? All right, now, so into 6, what's that equal to? Sir, can you please show how to solve part A with the regular method? Okay, I'll do that. 8 factorial divided by 4 factorial. Okay, into 6, that's equal to 10,080. So is this probability or anything? No. Okay, first let's complete this question, then we'll circle back to the previous one. So we count the tiles after the second M and add 1. Yeah, you can do that also. So basically 1 the way they are, then 2, 3, 4, 5, 6. Okay? All right. 5 letters are selected from the 10 letters in the word amalgamate. Find the number of different selections. So this is not probability. Okay, this is just asking us to find the number of different selections in which the 5 letters include at least 1 M and at least 2 A's. So that means the number of M must be greater than or equal to 1. Okay, the number of M's must be greater than or equal to 1. and the number of A's must be greater than or equal to 2. Okay? So we have 1m and 2 A's. Let's start with that. So 1, 2, 3, 4, 5. 1m and 2 A's. So here's an m, here's an A, here's an A. Okay? Now, what is the letter that we are talking about? We're talking about amalgamate. ठीक है? अच्छा, अब एक काम करते हैं. From this letter amalgamate, let's cross out the A's since we have to make sure we don't end up selecting any more A's. We've already selected 2 and we don't want any more. And let's cross out the M's because we've already selected 1 and we have to make sure we don't end up selecting any other. So what's this going to be equal to? We are now down to how many letters? We're now down to 1, 2, 3, 4. We're now down to 4 letters and we have to select 2. So that's 4C2. 4C2 is what? Is equal to 6. Okay, now let's keep the number of M's fixed and let's increase the number of A's. Okay, and then once again, let's keep the number of M fixed and increase the number of A's. That's it. I can't go more than 4 A's. Okay. What if I increase the number of M's to 2 and I keep the number of A's fixed at 2? That's also possible. Can I do 3 M's? No. But I can do 2 M's and I can do 3 A's. ये तो हम कर सकते हैं. We can do 2 M's and 3 A's. Can we do 2 and 4? No, that will make it 6. Yeah. All right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. Okay. 1m and 3s. So 1m and 3s. All right. So that means just 4C1, which is equal to 4. You can work this out mentally. 1m and 4a's. So that's just one way. Okay, there's nothing to work here. Then 2m's and 2a's. So m, a. So that's going to be 4C1, which is also equal to 4. Then 2m's and 3a's. So m, a. And that's equal to 1. So 6 plus 4 is 10. 10 plus 5 is 15. 15 plus 1, that's equal to 16. That's it. Okay. All right. Now. Okay. अच्छा वैसे ये भी थोड़ा मुश्किल सवाल है बाय द वे स्पेशली जो इसका पार्ट बी है ना इफ़ आई रिमेंबर करेक्टली मई जून 2025 पेपर 5 वेरिएंट 1 इसको भी कर लेते हैं ठीक है फिर विल डू द एलिगेटर क्वेश्चन आल्सो विल डू द एलिगेटर क्वेश्चन विल डू द हैप्पीनेस क्वेश्चन डोंट वरी सर द एलिगेटर क्वेश्चन पार्ट सी इट सेज द नंबर ऑफ डिफरेंट सिलेक्शंस 5 लेटर्स व्हिच कंटेन एट लीस्ट सो one possibility could be A now to C1 अच्छा I'll do the alligator question okay I will do oh अच्छा okay वो भी कहा था alligator question भी कर लेंगे I'm not saying we'll do it immediately but we will do it so we'll do the alligator question before we stop we'll do the crocodile question before we stop we'll do the happiness question these 3 questions inshallah I promise I will do them ठीक है पहले मैं ये बता दूँ हाँ अच्छा इसका करने का ऑल्टरनेटिव तरीका आपने पूछा था कुछ प्लीज शो अच्छा इसमें नहीं है ऑल्टरनेटिव मेथड इसमें यू कांट डू टोटल माइनस टुगेदर व्हाई बिकॉज द क्वेश्चन सेज नॉट नो एज आर टुगेदर सो आई एम अफ्रेड टोटल माइनस टुगेदर विल नॉट वर्क ओवर हियर ठीक है देयर इज़ नो रेगुलर मेथड ओके देयर इज़ नो सब्सटीट्यूट फॉर द फेंस पोस्ट मेथड ऑल द टाइम टोटल माइनस टुगेदर विल नॉट वर्क ओवर हियर ओके Sir, there's also another question of a group of men and women selections. Its part C is a bit tricky. Because, देखो सवाल तो पढ़ो, when you do total minus together, you only find out the number of ways in which they're not all together. Here, we're not supposed to find out the number of ways in which they're not all together. Here, we're supposed to find out the number of ways in which none of them are together. There's a difference. Okay? Zakaria, didn't I already answer your question? I said, here it is. Here's the answer to your question. Okay, when we use the fence post method, when do we use... when we use the total minus together Okay, now remember, I'll explain it again. If the people that you have to separate are 2, you can do it either way. You can do it using fence post, or you can do it using total minus together. If the number of people that you have to separate are 3 or more, okay, 3 or more, doesn't matter whether it's 3, 4, 5, then you have to see what does the question say. Does it say that not all are together, or does the question say that no 2 are together? Okay, if the number of people are, let's say, 5, and the question says not all are together, then the only way you can do it is total minus together. But if the question says 5 and the question says no 2 are together, then you use the fence post method. Okay, it's literally right in front of you. Fence post method works when there are 2 objects and no 2 are together, and if you want to apply no 2 are together to more than 2 objects also. But if the question says not all are together and there are more than 2 objects, then the fence post method doesn't work. Then what you use is you use total minus together. Okay? And if the question says no 2 are together and the number of objects that you have to make sure are not together are more than 5, then you are more than 2, then you cannot use total minus together. The only way it works is using the fence post method. Simple. Okay? All right. Sir, for amalgamate said no A's are together. How did you know it meant? Nahi beta, it says no A's are together. No A's are together, that means no A's. No 2 A's, no 3 A's, no 4 A's, no 5 A's. Okay, so if it says no A's are together, or if it says no 2 A's are together, it's the same thing. See, there's a difference between no A's are together and not all A's are together. No A's are together means that none of them can be together. ठीक हो गया? Yep, completely separated. That's correct. What if we do total minus 4A together? अच्छा, ये आपको करके देखना पड़ेगा, ठीक है? But really, why would you want to do that? Why would you want to do the 2 together, 3 together? Hania, beta, I've already solved the activated question. Okay? I'm not going to do that again. Okay? I don't understand. Why can't we use the total? Okay. Total minus together हम जब करते हैं, जब सवाल बोले कि not all are together. That means here there are 4 letters. Of the 4, 3 can still be together. If the question said not all are together, that means 3 can still be together, 2 can still be together. So that is why we do total minus together, so that we can make sure that not all of them are together. ठीक हो गया? Is the question saying not all are together, or is the question saying no A's are together? Read the question. Is the question saying not all are together, or is the question saying no A's are together? Question for you guys. सवाल क्या कह रहा है? सवाल पढ़ के आपको क्या लग रहा है कि 2 A's, 3 A's, 7 हो सकते हैं? Read the question and tell me read the question and tell me what you think. Can 2 A's be together here, or can 3 A's be together? No, they can't be. So that means you have to separate all of them. How do you separate all of them? You separate all of them by using the fence post method. ठीक है? Okay. Now, let's move on. ठीक है? अब इससे ज़्यादा टाइम हम नहीं स्पेंड कर रहे इस क्वेश्चन पे. ठीक है? अभी भी आपको नहीं समझ आ रहा तो बेटा सवाल पढ़ो and review the notes. Question number 5. No, actually not question number 5. This is May, June 2025, paper 5, variant 1. Okay. In a group of 20 musicians, there are 9 guitarists, 6 pianists, and 5 drummers. 6 musicians are selected from these 20 to perform at a concert. Find the number of different ways in which the 6 musicians can be selected if there must be at least 3 guitarists, at most 2 pianists, and exactly 1 drummer. Okay. At least 3 guitarists means that the number of guitarists must be greater than or equal to 3. At most 2 pianists mean that the number of pianists must be lesser than or equal to 2. And exactly 1 drummer means that the number of drummer must be equal to 1. That's it. This is non-negotiable. Nahi beta, please don't watch this for admats. ठीक है. जवाब नहीं दे रहा. किस चीज़ का जवाब नहीं दे रहा? आपने क्या सवाल पूछा? I don't see a question. Didn't we just do this question? We did a question similar to this. Basically, the reason why I'm solving this question is because of part B. Part B is a bit interesting. Okay, but we did a question similar to this. Okay. Achha, bear in mind that we have to select how many? We have to select 6 musicians. Okay, so we cannot exceed the total by 6. Okay. Now, how many guitarists do we have? We have a total of 9 guitarists. How many pianists do we have? We have a total of 6 pianists. How many drummers do we have? We have a total of 5 drummers. Okay. Now, sir, have you done Casablanca? No, I haven't done Casablanca. So in part A, you multiplied by 4 factorial because of the 4 remaining alphabets. Yep, that's correct. Okay, so let's start with 3 guitarists, 2 pianists, and 1 drummer. Okay, remember the total must be equal to 6. Okay, so 9C3 into 6C2 into 5C1. Let's work this out. Sir, ye question, I don't want 9C3 into 6C2 into 5C1. That's equal to 6300. Okay, now. Then there is another possibility, and that is we increase the number of guitarists by 1. We decrease the pianist by 1, and we keep the drummer locked at 1. So that would be 9C4 into 6C1 into 5C1. Basically, drummer to ek hi rehna hai. 9C4 into 6C1 into 5C1, that's 3780. Okay, can I increase the... Yeah, I can increase the guitarist by 1. The question said at most 2 pianists. That means it's possible to have 0 pianists. Why not? Yeah. And 1 drummer, so that's still 6. So that's 9C5 into 5C1. And what's that equal to? 9C5 into 5C1. And that's equal to 630. Okay. 6300 plus 3780 plus 630, that's equal to 10710. So 10,710. Okay, now this was an ordinary part, pretty straightforward. This is not the reason actually why I wanted to solve this question. The reason why I wanted to solve this question was this. Play button aa gaya? Haan, play button to kab ka aa gaya? 3 bands will be selected from the original group of 20 musicians. Each band will consist of 3 guitarists, 1 pianist, and 1 drummer. Okay. 3 guitarists, 1 pianist, and 1 drummer. Yeah, this was easy. I do agree. No musician can be in more than 1 band. Okay. The first band selected will play at a concert in France. The second band selected will play at a concert in Italy. And the third band selected will play in Spain. Find the number of different ways in which these 3 bands can be selected. Okay, so that means we have to not just select the people in the band, but we also have to find out the number of ways they can perform also. Okay. So ek kaam karte hain. What's the order? The order is France, Italy, and Spain. Okay. So pehle hum France ko dekhte hain. ठीक है. So the first band will perform in France. The second will play in Italy. And the third and the final one will play in Spain. ठीक है? Okay, now, don't forget this situation. ठीक है? This situation still holds, okay? That you have 9 guitarists, 6 pianists, and 5 drummers. All right, now, so if let's suppose, so think of it this way, we're making groups, okay? Yeah, so think of it this way, we're making groups. Yeah, that is in fact exactly what we're doing. We're making groups, ठीक है? So इसको आप group 1 कह लो, इसको band 1 कह लो, ठीक है? इसको band number 2 कह लो, इसको band number 3 कह लो. Okay. And within groups, there are groups. Okay, within groups, there are categories. All right, so in the first band, there are 9 pianists. And how many do we need? We need 3 guitarists. So that means 9C3. Okay, so there are 9 guitarists and we need 3. So that's 9C3. Then there are 6 pianists to choose from to perform in France, and we have to choose one. And there are 5 drummers to choose from to perform in France, and we have to choose one. Okay? Now let's talk about the second performance, which takes place in Italy. Notice that we had 9 guitarists to choose from. We've already chosen 3. Now we're down to how many? Now we're down to 6. So there are 6 guitarists to choose from, and here also we have to choose 3. There were 6 pianists to choose from. We chose 1. Now we're down to 5. That means we still have to choose 1. So that's 5C1. And now we are down to 4 drummers because we had 5. There's already 1 performing in France. Now we're down to 4, and now we have to choose 1. So that's 4C1. Okay? Multiply. No, sorry, not हाँ multiply करेंगे. Because ये तीनों मिला के एक ही performance है. So we're going to multiply. We're not going to add. ठीक है? Yeah, we're going to multiply. Because selecting all of them for these 3 performances is one task. Okay, we're not looking at multiple ways of doing the same task. Okay, this is the same way of doing, this is basically one way of doing the same task. All right. So for example, here there are multiple ways of doing the same task. Here, there are not multiple ways of doing the same tasks. These 3 combined is one task, and that is what we're looking at. Yeah, this is basically one task that we're talking about. Okay, then let's look at the third performance, which is in Spain. Now notice that in Italy we had 6 to choose from, and we chose 3. So now we're down to how many? Now we're down to 3, and we still have to choose 3. Once again, in Italy there were 5 to choose from. We had chosen 1, so now we're down to 4. So we still have to choose 1. And in Italy there were 4 drummers to choose from. We had chosen 1. Now we're down to 3, and we still have to choose 1. So that's 3C1. Okay. When do we multiply? When do we add? When it's the same task, you multiply. When there are different ways of doing the same task, that is when you add. Okay? So 9C3 into 6C1 into 5C1 into 6C3 into 5C1 into 4C1 into 3C3 into 4 into 3. Whoa, ये तो कुछ ज़्यादा ही भयानक आंसर आ रहा है. 1 2 0 9 6 0 0 1 2 3 1 2 3 12,096,000. Yeah. No, you're not going to multiply it by 3. Because notice the question says that the first band will play in France, then in Italy, then in Spain. So no need to multiply it by 3. So why are you selecting an order and reducing the number of musicians? Because if the number of musicians are selected, then you will have to decrease them. Let's say एक band है, उसमें 20, उसमें 9 guitarists हैं. Now, from those 9 guitarists, 3 are performing in France, and we want 3 more for Italy. So that means now we have 6 to choose from. Okay? No, I don't think I've done the recorder question. I don't remember doing any recorder question, but we'll do that. Okay? This is one way. Okay? This is one way, because the question says find the number of different ways in which these 3 bands can be selected. So selecting these 3 bands is one task. That's why we're multiplying. And there's no other way that we can do this. So sorry, just entered now. Wanted to ask if I prepared well for P1 but found it hard. How do I prepare for retake? Well, figure out why you found it hard and work on those areas. Why did we multiply? Because selecting these musicians for the first, second, and third band is one task. So within the same task, we multiply. That's why we multiplied. So very hard recording question. My whole brain power went into solving it and couldn't do it. Achha, okay. Tell me if what question number it is from this worksheet, and I'll see if I can include it. ठीक है? Okay. मुझे गिटार पसंद है, नहीं मुझे नहीं पसंद. See, if there are multiple ways of achieving the same condition, like for example here, if there are multiple ways of achieving the same condition, see here there are many ways that you can select 6 musicians. Correct? There are many ways that you can select 6 musicians. So we work out each way and we add. ठीक है? अब मुझे बताओ मैं यहाँ पे multiply क्यों कर रहा हूँ? Because ये पूरी मिला के एक task है. This combined is one task. That's why I'm multiplying, not adding. Okay, and these three are basically three different ways of doing the same, of completing the same task. That is why we're adding. Okay. अच्छा, एक काम करते हैं, ये भी कर लेते हैं, 2025 के कर रहे हैं ना, तो चलो, let's do this happiness question. Finally, let's do the happiness question. So I don't understand how you figured out the number of musicians for each country. The question said so. Vani again, I'm not going to go back to the question, read the question. The question categorically said how many musicians you need. So that's how I figured out. ठीक है, अब आप लोग सवाल भी नहीं पढ़ रहे हो, तो मैं सवाल भी आप लोगों को point out करूँ, and then the method also. So do me a favor, at least read the question carefully. All right, let's do this question. Find the number of different arrangements of the 9 letters in the word happiness. All right, that's 9 factorial divided by 2 factorial for the 2 p's, divided by 2 factorial for the 2 s's. So that's 9 factorial over 2 into 2. That's equal to, this is probably the third time that we have come across this value. Or is it just me? 90,720. This is probably the third time we've come across this value. Right? Okay, now part B. Yeah, this happiness question is designed to take your happiness away, especially this part. Yeah, this part. ये part तो आसान है. Okay. Now, part B. Find the number of different arrangements of the 9 letters in the word happiness in which the first and the last letter are not the same as each other. Okay, now if we talk about how many ways they can be different, that would be way too many. So instead what we're going to do is we're going to do total minus same. So let's find out the total, and from the total let's subtract the number of ways that the first and the last letter are the same. Okay? Now, 1, 2, 3, 4, 5, 6, 7, 8, 9. अच्छा, सेम कौन कौन से हो सकते हैं? पीज आ सकते हैं. If you have p's in between, that means 1, 2, 3, 4, 5, 6, 7. So that's going to be 7 factorial upon 2 factorial because there are s's. And the same can be done with the 2 s's also. Okay, exactly the same thing can be done with the 2 s's. And if you do it with the 2 s's, the working will not be any different. S, S. So 7 factorial upon 2 factorial. इसको मिटा देते हैं. 7 factorial divided by 2 factorial. So simply 7 factorial upon 2 factorial times 2, whatever that is equal to. There we go. Okay, now part C. Part C says find the number of different arrangements of the 9 letters in the word happiness in which the 2 p's are together and there are exactly 2 letters between the 2 s's. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Achha. The 2 p's are together, so let's put the 2 p's in a box. Okay, they can shuffle amongst themselves. 2 factorial. Oh, okay, subtract nahi kiya. All right, guys, take it easy, 90720. 90720. That's equal to 85680. Okay. Okay. Now, so 2 p's are together and there are exactly 2 letters between the 2 s's. So 1, 2, and 3. Okay. Okay. Now, अब यहाँ पे I do understand कि ज़रा थोड़ी सी प्रॉब्लम हो सकती है. यहाँ पे हमें इसको ट्रीट करना पड़ेगा एज अ यूनिट, because we already have the two p's in a box. So that is why we have to make sure that we treat this as a unit. Otherwise, these two p's may end up in between the two letters that we have already, and that way we're not going to have the two that way we're not going to have exactly two letters between the two s's. ठीक है? अच्छा, अब एक काम करते हैं. First of all, let's settle what can happen inside the box. Okay, what can happen inside the box? Notice that how many letters do we have? We have how many letters? We have HAPPINESS. We have a total of 9 letters, but we've dealt with the P's, we've dealt with the S's. Okay, so that means how many letters are we down to? We are now down to 5 letters. Okay, that means we are now down to 5 letters. So what can happen inside? Inside this box, you have 5 different options and you have 4 different options. Okay? And now, how many units do we have? You have 1, 2, 3, 4, 5 units to shuffle. Okay? Now you have 5 different units to shuffle. So 5 into 4 for what's going on inside the box where you have 2 S's with 2 letters in between, and then you have 5 different units to shuffle, so that would be 5 factorial. Okay, so 5 into 4 into 5 factorial, and what's that equal to? That's equal to 2400. Okay, so why not 90720 minus 5040? तो बेटा वही तो किया मैंने, वही तो किया. ठीक है, I forgot to do it earlier, but I've done it now. I think you're watching. I think you haven't reached that part of the stream yet. ठीक है. अच्छा, wait. This isn't it. Okay, this isn't it. I didn't say that this is it. Hold on. Now, there is one condition that's possible. First of all, let's make sure we understand this condition really well, because the other one is pretty straightforward. Okay, the other one is pretty straightforward. So notice that we've put the 2 p's in a box. Okay, and we have to make sure that there are exactly 2 letters between the 2 s's. Okay, so let's do this again. Now, first of all, what we need to do is we need to settle what's happening inside this box. Okay, so why are we so worried about these 2 s's to begin with? Why can we not do this? 1, 2, 3, 4, 5, 6. Why can we not do 6 factorial and then see how many different places the s's can be? Why can we not do that? Why can we not do that? Why is it that we can't do that? We can't do that because if we do that, you know what's the problem? The problem is कि ये जो 2 p's है ना, ये possible है कि ये इन 2 s's के बीच में आ जाए, and there are already 2 letters between the 2 s's, which will increase the number of letters between the 2 s's. That means we're not fulfilling the condition anymore. Okay, so please understand that we can't do this. We can't do the following: 1, 2, 3, 4, 5, 6. We can't do 6 factorial. That is wrong. Okay. Reason why we can't do 6 factorial is because if we do 6 factorial, that means we're saying that the 2 p's together can shuffle with the remaining letters, in which case there is a possibility that these 2 p's come in between the 2 s's, and when they come in between the 2 s's, which already have 2 letters in between, we will no longer have 2 letters between the 2 s's. That is why we can't do this. Okay? So those of you who are saying alternative methods, hold on to that. Okay? We can only look at one method at a time. Okay, let's look at one method at a time. Okay, as far as the 2 p's in between the 2 s's are concerned, we will consider that separately, because we will make sure that there are only 2 p's between the 2 s's. Okay, if we do this, if we do 6 factorial over here, it's possible that we have 2 letters between the 2 s's and 2 p's also between the 2 s's, which should not happen. As far as SPPS is concerned, that is something we will consider separately. Don't worry about that. Okay? So this is the reason why we can't do this. Okay? Achha, अब the question is, what is the correct way of doing it? So what you have to do is you have to make sure that nothing goes inside of this box other than the 2 letters. Okay? Nothing goes inside of this box other than the 2 letters. Okay? Okay. Now, How will you make sure that nothing goes inside of this box other than the two letters? By first considering how many options do we have for the two spaces between the two S's. So we have 5 and 4. Why 5 and 4? Because notice that we have dealt with the P's, okay, and we have dealt with the S's. We have dealt with the P's and we have dealt with the S's. Okay, so there's 1, 2, 3, 4, 5. Okay. Now, I do agree this is a confusing question. Ye confusing hai. I mean, there's no doubt about that. So this means 5 into 4 for basically inside the box with two S's and two letters in between multiplied by 5 factorial. Why? Because there are, see, यहाँ पे भी तो एक letter आएगा, यहाँ पे भी एक letter आएगा. ठीक है? There's going to be a letter over here, there's going to be a letter over here, there's going to be a letter over here. Okay, so that's 1. So how many units do we have altogether? We altogether have 5 different units to consider. So that is why we're going to multiply it by 5 factorial. ठीक है? Yeah, you can also do 5p2. That's also correct. ठीक है? So this is basically one way that you can have two letters between the two S's and the two P's are together. So there is one more way as well. तो बेटा मैंने भी तो यही किया 5 factorial into 4 into 5. How is that different? How is that different? Achha, as far as moving the S's are concerned, we've already considered that because we're treating this as a unit. Okay, so when we treat this as a unit, we have considered the different places that the S can move. Okay, but we have to make sure that the S's move together with the two letters in between them so that P cannot come in between and change the number of letters that we have. Okay, not the number, cannot change the number of letters. Okay? Achha, ab let's have a look at the other possibility. The other possibility is 1, 2, 3, 4, 5, 6, 7, 8, 9. कितने? 9 है ना? Okay, so one possibility is that you have S, P, P, S. And let's lock them in a box. Okay, let's lock them in a box. And if you do that, you have 1, 2, 3, 4, 5, 6. So what's that equal to? That's equal to 6 factorial. So 5 factorial into 5 into 4, 5 factorial into 5 into 4, that's equal to 2400. And 6 factorial, what's that equal to? That's equal to 720. So add them up. 6 factorial into, beta, you can do 5 factorial into 5p2 also. That's exactly the same thing. Okay. 6 factorial plus 2400. So 720 plus 2400, that's equal to 3120. So the total is equals to 3120. There we go. Okay, 5 into 4 समझ नहीं आया मैं दोबारा बताता हूँ. देखो, what makes this question slightly unique is the fact there is not just one condition, there is not just a condition on the number of letters between the two S's, there is another condition as well. And the condition is that the two P's are together. Okay? Now, we have to make sure that in between the two S's there are only two letters. That is why we don't do what we did over here. Okay, that is why if you do 6 factorial over here, this is wrong. You can't do this. Okay? So what we do is we lock this box. We lock this box so that we can make sure that these two P's cannot end up inside this box. Because if these two P's end up inside the box while we still have two letters in between them, what will happen? We will no longer have two letters between the two S's. We will have more than two letters. Okay? Now the question is, what are the options that we have for the two letters between the two S's? Okay, what are the options that we have for the two letters between the two S's? Notice that we started with 9 letters. We've already placed 4 of them. So now we're down to 5. So that means we have 5 options here and 4 options here. Or I can see that you guys were saying, why not 5p2? So you can do 5p2 also. 5p2. And then after you've done 5p2, where is the 5 factorial coming from? Notice that we have 1, 2, 3, 4, 5. We have 5 units to shuffle. How many ways can we do that? We can do that 5 factorial number of ways. And as those of you are wondering about the S's shuffling, the S's can shuffle. The S's can shuffle because we're treating this as one unit. So it's possible कि S 2 piece से पहले आ जाए. It's possible कि S जो है वो 2 P's आए, फिर एक letter आए, फिर 2 S's आ जाएं with 2 letters in between. So we already take that into account when we do 5 factorial. Okay? Achha guys, I've already solved the amalgamate question. ठीक है? So please watch that part of the stream again. ठीक हो गया? Okay, अब इसको करने का एक और तरीका भी है. इसको करने का ना एक और तरीका भी है. I'm not too sure about that method myself, but I saw it somewhere. And I'll explain it to you guys. Why did we solve this question in 2 steps? Because there is a possibility, the one possibility that we hadn't considered was having 2 P's between the 2 S's. Okay? We did not consider the possibility of having 2 P's between the 2 S's. Okay? How many marks to permutations and combinations? Beta, solve enough past papers, you'll figure it out. Okay? Don't be lazy, solve enough past papers, you'll figure it out. Okay? When to apply the gap method and when to minus from total, I've already explained that multiple times, and I've also shared my notes where you can see when we do it and when we don't. Okay? Now, let's have a look at the examiner report of this question. Somebody pointed out earlier that we should read the examiner report of this, and I think that was a good suggestion, so let's do that. एक सेकेंड इसकी एग्जामिनर रिपोर्ट पढ़ते हैं. दिस इज क्वेश्चन नंबर, ओके पेपर कौन सा है? पेपर 5 वेरिएंट 3 एंड दिस इज क्वेश्चन नंबर, आई डोंट हैव द एक्चुअल क्वेश्चन नंबर, अभी देख लेते हैं. एलिगेटर कर रहे हैं एलिगेटर. टेक इट इजी. This is part C. Okay. अच्छा, वैसे एग्जामिनर रिपोर्ट में ऐसी कोई ख़ास चीज़ नहीं लिखी हुई. Okay. There is nothing special in the examiner report that's worth reading. I'll show you guys here what the examiner report says. Like I said, there's nothing really in the examiner report that's worth reading. Strong candidates added the number of ways the letters could be arranged with 2 P's between the S's to the number of ways they could be arranged with the 2 P's outside the 2 S's. Less successful candidates split the problems into more parts, and usually looked either at the positioning of the S's or at the positioning of the P's. This made the problem significantly more challenging, and few of these achieved full marks. Candidates need to appreciate that they need to make their method clear to the reader or marker. Unless there is a clear explanation for working, credit cannot be awarded. Okay, so whatever it is that you're thinking, you have to translate it on paper as well. Okay, now, so let's do part D. The 9 letters in the word happiness are divided at random into a group of 5 and a group of 4. Find the probability that both P's are in one group and both S's are in another group. 5P2 means there are 5 letters to arrange, and you have to arrange 2 of them. That's why we're doing 5P2. ठीक हो गया? Okay. Now, this 5P2 means that there are 5 letters to arrange, and you only have to arrange 2 of them. So that's why we do 5P2. Okay. Now, the 9 letters in the word happiness are divided at random into a group of 5 and a group of 4. Okay, so 1, 2, 3, 4, 5. This is a group of 5. 1, 2, 3, 4. Find the probability that both P's are in one group and both the S's are in the other group. So it's possible that the P's are in a group of 5 and the S's are in a group of 2, which leads to the conclusion that to fill the remaining places in the group of 5, there are 5 letters to choose from. 1, नहीं H क्यों क्रॉस किया, P क्रॉस कर देते हैं, S क्रॉस कर देते हैं. There are 5 letters to choose from, and we have to choose 3, so that's 5C3. And there are 2 letters to choose from, and we have to choose 2, so that's going to be 2C2. So this will be 5C3 into 2C2, What is that equal to? 5c3 into 2c2, that's equal to 20. Is this the only way, or is there another possibility? There is another possibility. Another possibility is that instead of placing the two p's in the group of 5, you place them in the group of 4, and you place the two s's in the group of 5. Okay, that's also a possibility. Which leads to the conclusion, exactly the same thing, no? You have 5 letters to choose from, so that's 5c3 into 2c2. So there you go. So this also is 5c3 into 2c2, which will also be equal to 20. So that's 20. And what about the total? So what are we doing here? We are selecting, there are 9 letters and we're dividing them into a group of 5 and 4. So that's going to be 9c5 into 4c4. So the total is equal to 9c5 into 4c4. 9c5 into 4c4, that's equal to 126. So 20 divided by 126. 20 divided by 126, what's that equal to? That's equal to 10 upon 63. There we go. 5c3 is 10? Oh, okay. 5c3 is 10. Yeah, you're right. So 2 wrongs made 1 right. 10 and 10. There we go. I did 2 wrongs, or that made 1 right. 5c3 into 2c2, that's 10. Yeah. Okay. So won't we take individual probabilities? Why would you take individual probabilities? Because 2 p's are selected, right? So you would do 2c2. ठीक है, 2c2 करो या ना करो, it makes no difference. All right. Okay. Now let's do the. So is there more part to this? No, there isn't. ठीक है. अच्छा, अब हम करते हैं वो एलिगेटर वाला सवाल. एलिगेटर वाला सवाल करेंगे, क्रोकोडाइल वाला करेंगे, कुछ सीटिंग वाला करेंगे, एंड देन we're done. This is also a nice question. Ollie and Petra. Andromeda वाला सवाल भी अच्छा है. This is also a nice question, by the way. 2025 February, March. But first let's do the alligator and the crocodile question, okay? Because I've already committed to do those questions, so let's do those first. Okay. Here we are. Find the number of different arrangements of the 9 letters in the word crocodile. Okay, this is question number 23 of this worksheet. अच्छा, ये सवाल करते हैं, फिर हम एक नमाज ब्रेक लेंगे. So yeah. So we have 9 factorial divided by, this is May June 2022 paper 5 variant 2. 9 factorial divided by crocodile. So we have 2 C's. Okay. So we're going to divide by 2 factorial. We have 2 O's. So we're going to divide by 2 factorial. And we have any other letter that's repeating? No. So once again, we have 90,720. Okay. There we go. Variance, standard deviation. Variance and standard deviation. No. Maybe tomorrow. Tomorrow maybe. Okay. Now this is not the last question. We're going to do some seating arrangement questions as well. Okay. Then the question says, find the probability. Find the number of different arrangements of the 9 letters in the word crocodile in which there is a C at each end and no 2 O's are together. So we can do total minus together. We can use the fence post method because 2 O's है ना. So हम कोई भी method कर सकते हैं. There are 2 O's, so we can use any method. So there's 1, 2, 3, 4, 5, 6, 7. So we're using the fence post method. Table X, table Y wala, हाँ वो भी कर लेंगे. We're going to do some seating arrangement questions as well. Okay, now. So we have to make sure that there is a C at each end. So we place the two C's at each end. And no two O's are together. So that's 1, 2, 3, 4, 5, and 6. Okay. If one of these... please don't do that. Okay, so there are 6 places that we can place the two O's. So that's going to be 6p2 divided by 2 factorial multiplied by 1, 2, 3, 4, 5. So multiplied by 5 factorial. ठीक है. अच्छा 5 factorial में कोई repetitions हैं. C और O के अलावा there are no repetitions, so that's it. So what's this equal to? 6p2 divided by 2 into 5 factorial. That's equal to 1800. 1800. Okay, if you want to do total minus together, go ahead. Do total minus together. That's it. Okay, what else? 4 letters from the 9 letters in the word crocodile are selected. Selected means combination. Find the number of different selections in which the number of C's is not the same as the number of O's. Okay, so the number of C's is not the same as the number of O's. All right. So let's say that we have 1 C and 0 O. ठीक है. अच्छा अब ये 0 O कैसे करें और सही है. Let's say that you have 2 C's and no O लिख लेते हैं. चलो ठीक है. Because वो 0 0 confusing लग रहा है. ठीक है. You can't have 3 C's. So you can have 0 C and 1 O. Okay. And you can have 0 C and 2 O's. Or maybe you can have 2 C's and 1 O and the opposite. 2 C's, no, 1 O and 2 C's. और कुछ हो सकता है? 1 2 2 2 तो हो नहीं सकता. 2 1 0 2 0 1 2 0 1 0. Yeah, that's it. Okay. Now, so 1 2 3 4 5. No wait, not 5. 4 actually. Okay. Now, the word that we're dealing with is crocodile. So if I'm selecting 1 C and I have to make sure that I only select 1 C and I don't select any other O, so I'm going to do 1, 2, 3, 4, 5. So that means now we're down to 5 letters and we have to select 3 of them. Okay, so C has been selected. So 5C3. अच्छा कोई साथ में ज़रा ये work. I want someone to work this out. Have I done something wrong? 1 O and 2 C's. इसमें क्या गड़बड़ है? ओ अच्छा मैंने वो रिपीट कर लिया. Oh yeah. I've repeated that because I've already done 2 C and 1 O. Okay, of course I can't do that. ठीक है. So लेकिन फिर भी कुछ मिसिंग मुझे लग रहा है. 1 C and 2 O ये हमने कंसिडर नहीं किया. Yeah, 1 C and 2 O. ठीक है, ये नहीं कंसिडर किया हमने. सही है. Alright, so 2 C's. That means now we're down to 5. We have to select 2. So that's 5C2. 0 C and 1 O. So once again 5C3. 0 C and 2 O's. So that's going to be 5C2. 2 C and 1 O. So this is going to be 5C1. And then 1, 2, 3, 4. 1 C and 2 O. So that's also going to be 5C1. Okay. So 5C3 is equals to 10. 5C2 is also equal to 10. 5C3 is also equal to 10. 5C2 is also equal to 10. 5C1 is equals to 5. 5C1 is equals to 5. So that's 10, 20, 30, 40, 50. 50. Do we have to find out the probability? No. Thank God probability hota, so we would have to do all the work all over again. There you go. Okay, now part D. Now, before I solve part D, let me give you guys a disclaimer. Because this is not probability, that's why we're not doing 2C1 and for selecting one O or for selecting two Cs. So disclaimer. The disclaimer is Cambridge got this wrong first. Okay? And then issued the updated marking scheme for this question. ठीक है? So ये disclaimer याद रखिएगा कि Cambridge got this wrong first and then they issued an updated marking scheme with the correction. ठीक है? I'll turn this bold. And it's actually not the first time they've gotten this wrong. They've gotten questions like these wrong multiple times. एक पुराना सवाल था where there was another question. I think it was about two groups being identical and one different. So they got that wrong also. ठीक है? All right, now let's begin. अब आप लोगों ने कहा है करने को तो हम कर लेते हैं. ठीक है? So the question is this. Find the number of ways in which the 9 letters in the word crocodile can be divided into 3 groups. So 9 letters, we're making 3 groups, each containing 3 letters if the 2 C's must be in different groups. Okay. So first of all, let's look at all the possible ways this can happen. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. ठीक है? इसको मैं इधर रख देता हूँ so that I have enough space to solve this question. ठीक है? Okay. Now, I've noticed that other than the C, there is also something that we have to be careful of, and that is the O. Okay, that is the letter O. अच्छा, अब हम एक काम करते हैं. So this is the first group, this is the second group, and this is the third group. Let's place the C in the first group. Let's place the C in the second group. Okay. Let's place the O in the first group and let's place the O in the second group. Now you might say, okay, why are we dealing with O's to begin with? The question doesn't say anything about O's. And you're right, it doesn't say anything about O's. But do you know why we have to be careful about O's? Because if I make a group like this with CO and then a third letter, and then if I make another group of 3 with 2 letters, CO, and then a third letter, then there is a possibility of these two groups being identical. There will be a possibility of these two groups being identical. Okay? Yeah, of course, O can be together. We're going to talk about that later. Okay? Acha, let's work this out. So, in the first group, notice that we have dealt with the 2 C's and we have dealt with the 2 O's. That means now we're down to how many letters? Now we're down to 5 letters and we have to select one. So that's going to be 5C1. Okay. And then we're down to how many letters? Then we're down to 4 letters and we have to select one. So that's going to be 4C1. And then we're down to how many letters? We're down to 3 letters. So that's going to be 3C3. But remember, when you work this out, there is something to watch out for. Okay, what is that? Let's talk about that. When you do this, there is still something to watch out for. And what is that? Let's talk about that. So basically, you will do 5C1 into 4C1 into 3C3. The fact that these two groups are identical. Okay? The fact that these two groups are identical, so we're going to divide it by 2 factorial. Okay? So what is this equal to? This is equal to 10. Okay? Achha, I haven't, those of you are asking if I've come across a question similar to this, I haven't. The updated marking scheme was basically shared on their official portal and the websites did not update. Okay? In the wrong marking scheme, the answer to this question is 80. In the correct marking scheme, it's 65. Okay? So this question became a matter of debate. A lot of teachers emailed and This is basically what happened. Okay. Anyway, so why are we dividing by 2 factorial? I'll explain. So notice that these two groups are technically identical. Okay, why can they be identical? Here is the reason. These two groups could potentially be identical. कैसे मैं बताता हूँ? Let's suppose that the first group has CO, which we have fixed obviously, and the third letter is R. And then the other group, the second group, has CO because we've fixed, and the third letter is a D. Okay? The reason why I did not divide in the musicians question is because we're dealing with people. People are different. These are letters. Letters and objects can be identical. Okay? So use your common sense, beta. Now, if I swap the R and D, so what do you think? Is this the same or is this different? This will be considered the same. Okay? So we have one group with COR and we have another group with COD, and then we're saying there is another way to make a group of 3, that is COD in one group and their COR in another group. So because this is considered the same, that is why we're dividing by 2 factorial. Okay? Acha. Now, and in both the cases, in the third group, you will have the remaining letters, which is ILE, and here also in the third group, you will have the remaining letters, which is ILE. ठीक है? अब ये basically क्या है? ये same है. इसको हम different, we can't consider this as different. Okay? So this group, these 3 groups, if you compare them with these 3 groups, you can't say that they're different. Okay? Just because the order in which we've written is different does not make them 3 different groups, does not make them 2 different ways of making 3 groups. Okay? It's the exact same thing. So that because, and why is that? That's because the first 2 groups, both of them have CO. That is why. Okay? All right. Now, let's look at the other possibility. We have to make sure that the 2 C's are in different groups. Okay? So we can't put the 2 C's in the same group. All right. So if I put the 2 C's in different groups, another way that this can be done is this. You put 1, 2, 3, 4, 5, 6, 7, 8, 9. Sir, can any other letter be in place of O? Yeah, that's possible. Okay. So what we have done so far is we've considered one possibility. Let's consider more possibilities. Okay. So one possibility is that we have C in the first group, and then the other C we have in the second group. Okay. And then the 2 O's, we keep them separate. Okay. The reason why we're dealing with O's is because they're repeating. That's why we're dealing with O's separately, because they're repeating. If there was no other repetition other than the 2 C's, then we wouldn't have had anything to worry about. Because O's repeat, and because of O's repeating, there is a chance of the 2 groups being identical. That is why we're being extra careful. Okay? Now, once again, for this group, we will do 5C2 because we're down to 5 letters and we have to select 2 of them. Then we're down to 3 letters, we have to select 2 of them, so we're going to do 3C2. Then we're down to 1 letter and we have to select 1, so we're going to do 1C1. So now we have 5C2 into 3C2 into 1C1. And once again, what is the one thing we have to watch out for? We have to watch out for the fact that these 2 can be identical. Okay, so because these 2 can be identical, what are we going to do? We're going to divide by 2 factorial. Okay, and what's this equal to? This will be equal to 5 into 3, that's, no wait, 5C2, that's 10, into 3C2, that's 30. So 30 divided by 2, that's equal to 15. How can they be identical? Okay, I'll explain. If I don't divide by 2 factorial, this is what we end up doing. So there will be, let's suppose CDE, okay? So crocodile. And then you will have CRI. And then here you will have OOL. And then what if we have CRI in the first group, CDE in the second group, and then OOL in the third group? What do you think? are these the same or different? Will you consider these two to be the same or different? They're the same groups. Okay, it's basically exactly the same. So if you have CD in one group, CRI in another, and OOL in another, this is the same as having CRI in one, CD in another, and OOL in the other. Okay, so they are basically the same. That is why we divide by 2 factorial. ठीक है? अच्छा, bear with me. There are 2 more possibilities, and I've already run out of space. Okay. Sir, please, sir, why are you doing combination, not permutation with these type of divide questions? Dekho, this is combination, but the groups are identical. Okay, if the groups are identical, what do you do then? You divide it by factorial. Okay, if the groups are identical, what do you do then? You divide by factorial. Okay, देखो एक काम करते हैं, यहाँ पे देखें आप. Even though this is primarily combination, but you still have to watch out for the fact that the groups are identical. Just for example over here. Find the number of different ways 4 people A, B, C, D can be placed at random into 2 groups of 2. You're going to do 4C2 into 2C2 divide by 2 factorial. Why? Because the groups are identical. Okay, because the groups are identical. 12 people are placed at random into 3 groups of 4 people each. Find the number of ways this can be done. 12C4, 8C4, 4C4. Because the groups are identical, all the 3 groups are of 4 people each, we divide by 3 factorial. Okay? And then here, because the groups are not identical, then we do not divide by any factorial. Okay? So whenever the groups are identical, you divide it by factorial. Okay? Okay, now, so we have considered 2 possibilities, and if I'm not wrong, I think there are 3 more to consider. Yeah. Okay, so let's keep going. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we've considered the possibility of C in the same group as O, then another C with the same group as another O, then we've considered the possibility. Okay, what's left now is to consider the possibility that you have CO, and then you have C, and then you have another O. ठीक है, ये रह गया. CO को एक group में डाल देते हैं, फिर the other C in another group, the other O in another group. Okay, now here we don't have to consider any repetitions. So this will simply be 5C1 into 4C2 into 2C2. So 5C1 into 4C2 into 2C2, what is that equal to? Let's have a look. 5C1 into 4C2, this is equal to 30. No need to divide this by anything. Okay, another possibility to consider is the fact that COO, the fact that we have C along with the 2 O's in one group. So COO, and then you have COO, C. ठीक है. So this will be 5C2 into 3C3. Sorry, 5C2 into 3C3. 5C2 into 3C3. So 5C2 into 3C3, what's that equal to? That's equal to 10. Okay. Last. देखो, this is one of a kind question. ठीक है? Exam में ये सवाल आए, and given that you haven't completed the rest of the paper, my advice is just leave it. Okay? C, CO, and O. Have we considered that? C, CO, and then O. No, we haven't considered that. Let's consider that. Okay, let's consider the possibility that in the first group we have C, then we have CO in another, and then we have C. C, CO, and O. बाकी बात हमने consider नहीं किया. CO, CO, C, COO, CO, CO. No, we have considered this. What we haven't considered is C, C, and OO. नहीं, वो भी हमने consider कर लिया. क्या रह गया है फिर? एक चीज़ रह गई है. There is something that's left. 15, 15. No, I think we've considered all of them. Yeah, we've considered all the cases. Yeah. मौत रह गई है. Okay, so let's find out the total now. So the total is equals to 10 plus 15 plus 30 plus 10. So that's 25. 55 plus 10, what's that equal to? That's equal to 65. There you go. Okay. There is no other possibility that we haven't considered. So we've considered keeping CO in one group and the other pair of CO in the other group. That's done. C in one group, the other C in another group, and the two O's in the third group. Then there is a possibility of CO in one group, C in another, and O in another. Then COO in one group and the other C in another group. ठीक है. So that's it. ठीक है. अब एक नमाज break लेते हैं. And then after that, what question is left? We've done the crocodile question. I think I will do the alligator question next. And then we will do some seating questions. Okay? So yeah. Let's take a break now. Love from Jamiatul Rashid. Chana, I appreciate that. Thank you. AdMath mock. AdMath वालों को क्या tension है? AdMath में there is plenty of time. Okay. All right, fellas. See you after namaz. Okay, guys. Mock, I'm not doing a mock this year, guys. I am not doing a mock this year, but I've made my last mocks public, so you guys can check those out. Okay? Sir, but like, why are we just replacing the same letters in both group, like if it was CIR and then CD and OL? Then they won't divide by 2 factorial? In that case, they won't. Okay, the arrangement that you have talked about, us case mein we won't divide by 2 factorial. Okay? But when do we divide by 2 factorial? When the members of the groups are identical. That is when we divide by 2 factorial. Like for example, if let's suppose you have COD in another and you have COR in another, and then you have COR in one and COD in another, that's considered identical. Okay? All right, now let's do some seating related questions. Okay, let's do some seating related questions and then we will end. Let's aim to finish inshallah at 8. So let's do some seating related questions that we haven't done so far. There was one seating question that I came across earlier. I think I even circled it. Yeah, let's do this one. Yeah, alligator, crocodile कर तो लिया बेटा, अब कितना crocodile करोगे? कर तो लिया crocodile. आप सो रहे थे क्या बेटा? We've done crocodile now. ठीक है. So let's do this question. Let's do question number 33. Let's see what this is. Beta, we've done the crocodile question. How many times do you want me to do it now? The last question before the break, that was the crocodile question. I've done it. So, alligator, yeah, alligator कर लेंगे. ठीक है. Number related question, yeah, I haven't done some number related questions. Okay, so let's do that also. In a restaurant, the tables are rectangular. Each table seats 4 people, 2 along each of the longer sides of the table. 8 friends have booked 2 tables, X and Y, R, S, and T. Okay. Those are the initials, or 3 of these friends. The 8 friends will be divided into 2 groups of 4, 1 group for table X and 1 group for table Y. Okay. Find the number of ways this can be done if R and S must sit at the same table as each other, and tan must sit at the other table. Okay, so first let's make sure that R and S sit on table X. So R and S but not T. Okay, R and S but not T. Okay. So we have to make sure that on table X we place R and S, Raj and Rajid and Su, and Tan is on the other table. Okay. So notice that there are 8 people. Okay. So 8 may say, let's subtract 2 because of R and S, and also let's subtract 1 because of T. So how many are we down to? We're down to 5. ठीक है. इसके बाद alligator कर लेंगे. No problem. ठीक है. So for table X, now we're down to, so we made sure that R and S are sitting at table X, and we've made sure that tan is sitting at table Y. So that means of the 8 people, 3 people have already been taken care of. So how many are we down to? We're down to 5. And we have to select 2 people for table X, so that's 5C2. And as far as the other table is concerned, as far as the table Y is concerned, we have 3 people left and we have to select 3 people, so we're going to do 3C3. Okay, and what's that equal to? 5C2 into 3C3, that's equal to 10. And the same can be done with table Y also. Yeah, I was wondering the same. Who names their kid Dan? Okay. Now, the same can be done for table Y. That we make sure that R and S are sitting at table Y, but not T. ठीक है, तो हम R को यहाँ बिठा देते हैं, S को यहाँ बिठा देते हैं, T को बिठा देते हैं. Okay, so that means as far as table Y is concerned, there are 5 people to select from, and we have to select 2, so that's 5C2. And as far as table Y is concerned, there are 3 people left, and we have to select all 3 of them, so that's 3C3, that's equal to 10 also. Okay, so what's 10 plus 10 equal to? That's equal to 20. Beta, the what ifs pe focus nahi kare, let's focus on what is. Okay, so that's the answer. Because what if to kuch bhi ho sakta hai na? What if the paper gets cancelled? What if the paper gets leaked? Okay, so let's not focus on what ifs, let's just focus on what is right now. Okay, now let's do part B. Part B says, so 5C3 times 2C2. Why 2C2? 5C3 times 2C2. I'm selecting, so basically I'm completing this table first. I'm completing table Y first. For table Y, we have 2 people left to select from, and we have five people left to select from, and we have to select 2. Okay, so this is for table Y, and this is for table X. And here, this is for table X, and this is for table Y. Okay? So देखो, there are 8 people in total, and we have to make sure that 2 of them, R and S, are together at one table, and Tan, the third person, is not at the same table as R and S. So what we do is we first make sure, yeah, it works that way also. So we first make sure that R and S are sitting at table X. Okay, so we made sure earlier that R and S are sitting at table X, which means that T must be sitting at table Y. So how do you fill the remaining 2 places at table X? 5C2. Why? Because there are 8 people, 3 people's fate has already been decided. Now we're down to 5, and from these 5 we have to select 2 for the remaining members of table X. So that's 5C2. And for the remaining members of table Y, that's 1, 2, 3. We do 3C3. You do the exact same thing for table Y. That's it. All right, now part B. Part B says, when the friends arrive at the restaurant, R and Sue now decide to sit at table X on the same side as each other. Tan decides that he does not mind at which table he sits. ठीक है भाई, आसान है इनका. Find the number of different seating arrangements for the 8 friends. All right, so that means we don't really have to worry about Tan anymore. So 1, 2, 3, 4. This is table X. 1, 2, 2, 3, 4. This is table Y. So here's table X, here's table Y. Okay, now R and S have decided that they want to sit not just together but at the same side also. Okay, talk about being particular. So they want to sit together on the same side, and Tan, on the other hand, does not mind. Okay, so that means there are 6 people left. 1, 2, 3, 4, 5, 6. So as far as the remaining 6 people are concerned, we're going to do 6 factorial. Okay? But notice that R and S can shuffle. No, as long as they're sitting on the same side and they're sitting together, they can shuffle. So we're going to multiply it by 2. Okay? अच्छा, और क्या हो सकता है? और क्या हो सकता है? Anything else that we can consider? We also have to consider the possibility that R and S are sitting on this side. We also have to consider the possibility that R and S are not sitting on this side, but they're sitting on this side. So that means we're going to multiply it by 2 again. Okay? So with 6 factorial times 2, where does it tell that he's on the same side? Who, he? There are 3 people. Which one are you talking about? See, when we do 6 factorial, see, now we don't have to worry about tan. Okay, now we don't have to worry about tan. So that means other than R and S, there are 6 people left. So that means we're going to do 6 factorial. Okay? Now, what about R and S? R and S cannot sit at the other table. They must sit at table X. Okay, read the question. So R and S can swap places. Okay, R and S can swap places. Nobody's stopping them from swapping places. As long as they're sitting together and on the same side. And not only can they swap places, they can also swap sides, meaning they can sit on the opposite side as well. So we're going to multiply it by 2. Okay, now we're going to multiply it by 2. So 6 factorial, what is that equal to? 6 factorial into 2 times 2, that's equal to 2880. There we go. Okay. That's it. Acha, yahan pe you can do 2 factorial because there are 2 people and both of them can shuffle. You can do 2 factorial, but doesn't matter whether you do 2 factorial or 2, it's the same thing. 5c2 into 2 factorial into 2 factorial into 4 factorial. No, you can't do that. Because if you're doing 2 factorial into 4 factorial, you're assuming that you only have 2 options for this and you have 4 options for this. That's not the case. You need to combine these 6 parts and do 6 factorial. Sir, should we not multiply by 2 again? I did multiply it by 2 again. That's exactly why you see this 2. Okay, so the reason why you see this 2 is because of this. The reason why you see 2 factorial is because of this. Okay, now there's more. There is more. As they leave the restaurant, the 8 friends stand in line for a photograph. Find the number of different arrangements if R and S stand next to each other, but neither is at the end of the line. Okay, R and S stand next to each other, but neither is at the end of the line. So that means we have to make sure that at the end of the line, it's neither R nor S. So 1, 2, 3, 4, 5, 6, 7, 8. Now there are 8 friends. We have to make sure that R and S stand together, but they're not at the end of the line. So that means we will first make sure that there is a person standing already in the beginning. So we have 6 options to choose from. And there is another person standing at the other end, so we have 5 options for that. Okay, now R and S can shuffle amongst themselves, so that's going to be 2 factorial for R and S. Okay, so 6 into 2 factorial into 5. Now what about in between? In between there are 5 units and they can shuffle amongst themselves 5 factorial number of ways. Okay, so I repeat. So R and S must be together, but we have to make sure that they're not standing at the end of the line. So we will make sure that there is some other person from the remaining 6 standing on this side and some other person from the remaining 5 standing on this side. Okay, so that's why we do this 6 and then this 5. Okay, now R and S can shuffle amongst themselves, so that would be 2 factorial. And now we have 1, 2, 3, 4, 5 different units to shuffle. So we're going to multiply it by 5 factorial. So in the marking scheme, there is 6c2 into 2 factorial into 2 factorial into 4 factorial for the previous part. Okay, 6c2 into 2 factorial into 4 factorial. Answer same hai? Ya answer different hai? Marking scheme mein aap bol rahe ho ke there is different. What question number is this? This is 33. Let me check. Yeah, sometimes the marking scheme really does. Sometimes they make it overcomplicated. Sometimes they oversimplify. So I don't know what they mean by that. 6c2 means that they're selecting 2 people. Okay, so they have done 6c2 now. Haan, theek hai. So they've selected 2 people, then arranged them, then they have done. Okay. See, what's not okay is doing 2 factorial and 4 factorial. That is not okay. 6c2 वाली चीज़ सही है because उन्होंने क्या किया, पहले उन्होंने 2 लोग select किए, फिर उन 2 लोगों को arrange किया. That means now they're down to 4 and then they selected and then they arranged the remaining 4 people. Okay. All right, so once again, part C. Part C, we just have to make sure that R and S stand next to each other, but at the same time, we also have to make sure that R and S, neither of them stand at the end of the line. So that means we first have to make sure that R and S are not standing at the end of the line. So we place any one of the 6 remaining friends, and then for the last place, we have 5 options. Okay. So in between anything, no wait, before that we put R and S in a box and they can shuffle amongst themselves 2 factorial number of ways. So R and S together with 4 other people can shuffle amongst themselves 5 factorial number of ways. Solved PDF? Okay, I'll share the solved PDF once the stream ends, inshallah. Acha, then let's do the alligator question. Alligator. Kahan alligator question? Where is the alligator question? Okay, 26. All right. Any other seating related question? Let's do that. I mean, let's mark that. We will do it later. एक सवाल टैक्सी वाला नहीं था? चलो पहले एलिगेटर निपटाते हैं. So what's so difficult about the alligator question? Specimen paper 2020. Chalo, let's do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters. The 2 A's are together. So we put the 2 A's together. We put the 2 L's together. Now let's see what we end up with. So putting the 2 A's and the 2 L's together. Let's put them in a box. Let's put the 2 L's in a box. So we have 1, 2, 3, 4, 5, 6, 7. So 7 factorial. And other than the 2 A's and the 2 L's, are there any repetitions? I don't think so. Other than the 2 A's and the 2 L's, are there any repetitions? No, I don't think so. No. So that's it. 7 factorial. 7 factorial is 5040. You're welcome, Mariam. Appreciate that. I appreciate you appreciating. 7 factorial. That's 5040. Although Cambridge is making sure that these streams don't end. So yeah. Khair. Acha, let me see. Basically, sir, the alligator question part C says the number. Acha, we'll get to part C, don't worry. Sir, when you say a group can be identical, it's because the number of items in the group is the same. See, the number of items are the same and the items are also the same. Okay? So they can be identical because of the number of items and because of the items as well. So we have the answer. Kya answer aa gaya hamara? 7 factorial. That's it. Okay. Now, the 9 letters in the word alligator are arranged in a random order. Find the probability that the 2 L's are together and there are exactly 6 letters between the 2 A's. Okay, this should be fun. 6 letters between the 2 A's. ठीक है. So, एक काम करते हैं. First, let's make 9 left blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9. ठीक हो गया. Okay, so what do we have to make sure of? We have to make sure that the 2 L's are together. 5040 for the second time? Acha, I didn't know that. And there are exactly 6 letters between the 2 A's. Okay, so we have an A, 1, 2, 3, 4, 5, 6. ठीक है. अब यहाँ पे भी we have to consider 2 possibilities. Okay, in part B of this, we once again have to consider 2 possibilities. Why? Because the 6 letters that are between the 2 A's could also be the 2 L's. Okay, so the 6 letters that are between the 2 A's could be the 2 L's, could also be some other letter. So you have to consider both the possibilities. ठीक है? अच्छा, अब एक काम करते हैं. Let's put these L's in a box. Okay, and what do we have here? We have 1, 2, 3, 4. No, wait a minute. The question said that there are exactly 6 letters between the 2 A's. Did I make one less blank? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, okay. So this is not possible. This is not possible. 1, 2, 3, 4, 5. Yeah, तो ये तो नहीं हो सकता. So that means the only way this can work is if you place the two L's in the gap only. Okay, 1. Okay, that makes it a relatively easier question. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So if I place an L, then we have 6 letters. So that's 1, 2, 3, 4, 5, 6. And then we have another A. So that means the only way this can work is if the L's are in between. Okay. Yeah, this is the only way it can work. Okay, now. So this means 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Hold on, let me think. 6 factorial. 1, 2, 3, 4, 5, 6. Yeah, 6 letters between the two A's. Okay. So we have put the two L's in a box. Okay. So that means okay. We can't consider this 6. Yeah. So we will have to treat this. We'll have to lock this. ठीक है. इसको हमें lock इसलिए करना पड़ेगा क्योंकि अगर हम इसको lock नहीं करेंगे तो पता है क्या possibility है? The possibility is that the two L's will go outside and one letter will come in place of the two L's. So we have to lock this. Okay, we have to lock this. So we can lock this by doing 5 factorial. Okay, so 5 factorial. And then okay, wait a minute. इसको हमें लॉक करना पड़ेगा. ठीक है, क्योंकि अगर इसको लॉक नहीं करेंगे and if we treat L as a unit along with this, so there is a possibility that the two L's will go outside and in place of the two L's we'll have one unit, which means we will no longer have 6 letters between the two A's. Okay, so instead what we're going to do is, अच्छा एक काम करते हैं, पहले इसको settle कर लेते हैं. First let's settle this. How many options do we have for this place? How many letters did we start with? We started with 1, 2, 3, 4. We started with 9. How many letters have we dealt with? We've dealt with 4 letters. So that means we have 5 options over here. Okay? We have 5 options over here. Now, inside, there's 5 factorial and then multiplied by 5. Okay? So inside, we can do 5 factorial because they can shuffle. If they keep on shuffling, we will still have 5 letters. We'll still have 6 letters between the two A's. And how many options do we have over here? We have 5 options. Achha, but there is something else to watch out for. There is another possibility to consider, and that is this one right here. So another possibility to consider is this one. Okay, instead of starting from the first letter, we start from the second one. This is also a possibility that you must consider. Okay, and you place the L over here. So now once again, you have 6 letters between the two L's. You have 5 options here, and let's put the two L's in a box. So that means you have 1, 2, 3, 4, 5. So 5 into 5 factorial. Okay, so 5 into 5 factorial, what is that? 5 factorial into 5, that's equal to 600. And then 600 for this. So the total will be equal to 1200. There we go. Yeah, this is actually a question very similar to the one that we solved earlier. Kaun sa question tha? The happiness question. Yeah, similar to the happiness question. So here we are. Okay, now I'll explain this again. We can't keep the two L's before the two A's because if we do that, we do not have 6 letters between the two A's. Okay? So that means the only way to make this work is to make sure that the two L's are between the two A's. Okay. So we place an A here and we leave 6 blanks and then we place another A and we make sure that the two L's are in between. Now reason why we can't combine these 5 units along with the unit on the outside is because we can't shuffle all of them together, because if we do shuffle all of them together, what can possibly happen is that the two L's will end up outside and one letter will come in place of two L's, which means we will no longer have 6 letters between the two A's. So we deal with this letter separately. We have 5 options for this letter. Why? Because we started with how many letters? We started with 9 letters. We've placed 4 of them. So that means we have 5 options for the last. And inside this box, we have 5 different units to shuffle, and we can shuffle that 5 factorial number of ways. Okay? The order of 5 doesn't matter. Where you place the 5 and when you place the 5 factorials, that doesn't matter. ठीक है? उससे फर्क नहीं पड़ता. ठीक हो गया? Okay. Now, so this had probability. Okay. So there is more. So if this had probability, so total is 1200. 1200 को divide कर लेते हैं by the total number of arrangements, which is 5040. So the favorable is 1200. अच्छा, there is more space. Oh, there is more space. I did not realize that. So चलो, at least let's shift this here. And how do I make more space? इसको इधर ही रहने देते हैं. ठीक है, इसको erase कर देते हैं. So that means favorable is equals to 600 plus 600, which is 1200. And then as far as the total is concerned, the total is 5040. ठीक है. अच्छा, let me solve this, but I'll take your questions. 1200 divided by 5040, that's equal to 5 over 21. Okay, and that's it, 5 over 21. Acha, why 5p1 and not 5p4? Why would you do 5p4? Why would you do 5p4? You could do 5p4 for this and 5p1 for this. Or what you can do is this. You could do 5p1 for this and then 4p1 for this. ठीक है. And then you will still have to shuffle them as units. Okay, you will still have to shuffle them. So that means you will still have to multiply it by 5 factorial. For inner brackets, 5040 is not the total. Oh. Okay. Guess what the total is? Guess what the total is? The total is 90720. The total is 9 factorial upon 2 factorial into 2 factorial. 90720. Okay, so we'll have to do this again. 1200 over 90720. 1200 divided by 90720, which is equal to 5 over 378. Okay, now, अच्छा, अब क्या सवाल था आप लोगों का? What was the question? Sir, the examiner is following a pattern. Yeah, clearly. So why twice? I don't understand. Okay, reason why we've done it twice is because notice that A was the first and the second last letter. There is another possibility, that is A is the second and the last letter, which means that there will be 6 letters in between. That's why we've done it twice. Okay, why have I placed a 5 here? Reason why I placed a 5 here in both places is because once we're done with all the letters, once we're done arranging all the letters, we have how many options? We have 5 options for the last place. So that's why we have 5 options here and we have 5 options over here. ठीक है? चलें पार्ट सी करते हैं इसका, फिर हम एंड करते हैं. Find the number of different selections of 5 letters from the 9 letters in the word alligator, which contain at least one L, at least one A, and at most one L. इसमें क्या मुश्किल है? This is not a unique question. I don't see how this is a different question. This is the same one. चलें एक काम करते हैं, हम नंबर के जो क्वेश्चंस हैं ना, नंबर के क्वेश्चंस कल रख लें, क्या ख्याल है? लेकिन कल फिर हम वो वेरिएंस ऑन स्टैंडर्ड डिविएशन कब रखेंगे? At least one A and at most one L. At least one A means that you have one A and 0 L, one A and 1 L. You can have 2A and 0 L. You can have 2A and 1 L. और कोई possibility बची है? Any other possibility? That's it, I guess. So, do you guys really want me to solve this question? I don't see anything unique in this question. It's not probability, so it's not like you will consider repetitions. ठीक है. Okay. Last question. It's not a chocolate that I'm eating. Darts question. What is this darts question? Okay, let me see. One second, I don't have the dart. Do I have that question in this PDF? I don't think so. Is there? Let me find that question. Just give me a minute. This one? Run through we'll do tomorrow, inshallah. We are not doing a mock, guys. Mock inshallah हम लोग करेंगे, बल्कि नहीं करेंगे mock. Mock आप लोग कर लो. I've shared the mocks from last year. ठीक है, so you guys can check those out. I've added them in this playlist only. When I said we condition repetitions, I meant that if you have two A's to choose and it's a probability question and you have to choose one, so you'll do 2C1. That's what I meant. दूर होकर खाऊं. Is it really that clear? अच्छा, I'm solving this question now, pay attention. A darts club has 12 members made up of 7 men and 5 women. LMNK deserves a mention. Is that वो वाला independent? LMNK वो independent probability वाला question. Barcode. यार वैसे सही कह रहे हैं आप. अच्छा, आई थिंक लीक के बाद से कैमरेज वाले काफ़ी ठंडे हो गए. उन्होंने कहा कि यार नए नए पेपर लीक हो रहे हैं तो पुराने पेपर्स की तो खैर है. ओके, ऑलराइट. हाँ, तो I've already solved that question. I've already solved that question in probability. कल representation of data तो मैं नहीं करा रहा. I would rather do coded mean, variance and all that. Okay, let's solve this question. Question 6 says, a darts club has 12 members made up of 7 men and 5 women. Every Monday, a team of 4 is chosen at random to represent the club in a competition. Find the probability that on a particular Monday, a team consists of 1 man and 3 women. Okay, so probability is, the first thing you want to do is you want to find out the total. So the total would be 12 members and you have to select 4, so that's 12C4. This is May, June 2025, paper 5, variant 5. The Chinese variant. Which reminds me that apparently there is a new pandemic. Not pandemic yet, but apparently there's a new virus. I don't know if you guys have seen the news or not. Khair. Now we have to make sure that the team consists of 1 man and 3 women. So 1 man from 7, that means 7C1. 3 women from 5, so that means 5C3. Divide by the total, which is 495. अच्छा बेटा, ये आखिरी सवाल है, ठीक है? अब मेरी हो गई है बस, आप लोगों की भी बस हो गई होगी. So that's it, 495. And that's equal to 14 over 99. Yeah, exactly, that virus. ठीक हो गया? सही है? So I've done a lot of past paper, yet my permutation. The thing is, permutation, combination, and probability. These are 2 questions that can always surprise you. Okay, this is where the examiner can get really creative. So you just have to believe that whatever you've done is enough and be hopeful that you will come across a question that you can solve. So yeah. Okay, now, every Tuesday, the darts club chooses 3 teams of 4. Each team enters a competition in a different town. In how many different ways can the teams be chosen if there are no restrictions? So that means you have to basically make 3 groups of 4. That's it. So there are 12 people. So the first group that you make, you have 12 people to choose from. So that's going to be 12C4. And then you've chosen 4 people. That means now you're down to 8. So you have to choose 4. So that's 8C4. And then 4C4 once again. We use factorial when you have 5 people and 5 places. That's when you use 5 factorial. Okay? When the number of people that you have to arrange is equal to the number of space, that is when you use factorial. Okay, now, part C. In how many different ways can the teams be chosen if each team must contain at least 1 man and at least 1 woman? At least 1 man and at least 1 woman. Okay. Each group is different because they go to different towns. Yeah, so? अच्छा, ओके. अब यहाँ पे उन्होंने डिवाइड बाय 3 फैक्टोरियल क्यों नहीं किया? Okay. Yeah, the reason why they didn't divide, I think they learned from their mistakes. Okay? They learned from their mistakes and they did not divide by 3 factorial. Why? Because the question says that each team will go to a different town. Okay? But if the question was silent, we would have divided by 3 factorial. Okay? Okay, now. In how many different ways can the teams be chosen if each team must contain at least one man and at least one woman? Okay. So we now have to find out the number of ways a team can be chosen if it must contain at least one man and at least one woman. Achha, how many teams are we talking about? We're talking about 7 men and 5 women. Okay. Now. और ग्रुप जो है हमारे पास वो कौन से हैं? We have groups of 4. Okay, now 1, 2, 3, 4. 1, 2, 3, 4. And how many groups of 4? 3 groups of 4. 1, 2, 3, 4. Okay, now at least one man and at least one woman means that let's suppose each team must contain at least one man and at least one woman. So we can have 3 men. Can we have 4 men? No. We can have 3 men and 1 woman. We can have 2 men and 2 women. We can have 1 man and 3 women. हो सकता है ना? That is possible. Correct? Achha, but because they're going to different towns, there's something that you have to be careful of. Okay, achha, pehle to let's work this out. Okay, since they're going to different towns, we have to consider different arrangements of these groups also. So that's group 1, group 2, group 3. Okay, why? Because bear in mind that they are going to different towns. Okay, so हमें इसकी different arrangements भी consider करनी पड़ेगी. So how do you select 3 men from how many? From 7. So that's going to be 7C3. And how do you select 1 woman from how many? From 5. So that's going to be 5C1. Then into, now notice that you've selected 3 men from 7. That means now you're down to 4. And you have to select 2. And you've selected 1 woman from 5. So now you're down to 4. So you have to select 2. Okay. And then you are down to how many men? You are now down to 2 men and you have to select 1. Achha, wait, this is not possible. This is not possible. ये क्यों नहीं हो सकता possible? Because इसमें women जो है वो हमारे पास 1, 2, 3, 4, 5, 6 ये ज़्यादा हो गया. ये possible नहीं है. That means हमें कुछ और सोचना पड़ेगा. 3 men, 1 woman, 2 men, 2 women. एक काम करते हैं. Yeah. Here also we can have, wait, here also we can have, how many men do we have? We have, एक काम करते हैं ना यार, ये back and forth की वजह से we're losing track of the question. Let's keep this in front of us so that we don't lose track of how many men we have, how many women we have. Okay. So that means we can have another group. Okay, wait a minute. So we can, how many men do we have? We have 7 men. We can have another group of 2 men and 2 women. It's possible to have another group of 2 men and 2 women. Yeah, that's possible. We can have another group of 2 men and 2 women. Correct? So this means that we can now do, so we're down to 2 men, so that's 2C2, and we have to select 2, and we're down to 2 women, and we have to select 2, so that's 2C2. Okay? I've noticed that we can consider the different arrangements of these groups also. Okay, so how do we do that? We do that by 3 factorial, but from these 3 groups, these 2 are exactly identical. So because these 2 are identical, so what are we going to do? We're going to divide by 2 factorial also. Okay, so because they're identical, so we're going to divide by 2 factorial. Okay, now let's work this out. 7C3 into 5C1 into 4C2 into 4C2 into 2C2 and 2C2 not going to make a difference. So just do 3 factorial. Divide by 2 factorial. What's that equal to? That's equal to 18,900. But wait a minute. Let's not get carried away because I'm sure there is another way this can be done. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, now let's do this. Let's start again with 3 men and 1 woman. So that's men, 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 women. ठीक है. So एक काम करते हैं ना, men, 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 men. कितने 1 2 3 4 5 6 7. So 3 हमने select कर लिया, इनको cross कर देते हैं. Women कितनी है 1 2 3 4 5. We've selected 1 woman, so let's cross that out. Okay, and in group 2, can we once again do 3 men and 1 woman? I think we can. We can do 3 men and 1 woman. 3 men and 1 woman. So that's 1 2 3 and 1. And now we can do 1 man and 3 women. Yeah, so that makes sense. So that means 7C3 into 5C1 for group 1. Then we're down to 4 men. We have to select 3. So that's 4C3 into 4C1. Now we're down to 1 man. We have to select 1. So that's 1C1. Okay, so this is for group 1. This is for group 2. Okay. And then we have 1C1, 7C3, 4C3, 1C1 into 3C3. Yeah. And then do not forget the possibility that you can arrange them because they're going to be performing in different cities. So you're going to do 3 factorial. And once again, 2 groups are identical. So you're going to divide by 2 factorial. Okay. So, but since, okay, the people are different, but the groups are identical. You're right. The people are different, but the groups are identical. That is why we divide by 2 factorial. Okay. We're dividing by 2 factorial because the people are different, but the number of members in the groups are identical. That is why we're dividing by 2 factorial. Okay. So let's work this out. 7C3 into 5C1 into 4C3 into 4C1 into 3 factorial. So simply into 3 kar lete hain. So this is equal to 8,400. Does anyone know what the right answer is? 27,300. Can anyone confirm? Confirm कर दें, फिर हम आगे चलते हैं. People same नहीं हो सकते ना. पहली बात तो ये people same cannot, it's not possible. 9 7, I'm pretty sure 9 7 वाला वो आंसर नहीं है. Is the answer 27,300? Can anyone confirm? Yes or no? But I don't think I will be doing that chapter, but I saw Sir Zain cover that chapter recently, so you can cover it from his channel. Because we're short on time, and tomorrow I will most likely do variance. Why did I multiply? Because it's the same task. Making these groups is one task. That's why I've multiplied. See, this factorial is confusing if you lose context of the question. If you recall what the question says that they will be performing in a different town. Okay, so it's possible that this group goes to a different town and this group goes to a different town. Okay, it's possible, right? कि ये group town A चला जाए, ये B चला जाए, ये C चला जाए. Similarly possible है कि ये जो है वो B चला जाए, ये चला जाए, वो C चला जाए. वैसे I have a slight objection. Considering that these are people and they're gonna be going in different towns, so मेरे ख्याल में this should not be. Have they really divided by 2 factorial in the marking scheme? Because I have an objection that you should, because they're people, you should only multiplying by 3 factorial, not be dividing by 3 factorial. 27,200. लोग तो अलग है ना, वो अलग टाउन भी जा रहे हैं और लोग भी अलग हैं, तो I don't think you should divide by 2 factorial. Khair, I don't know, maybe an updated version of this might come out as well. Or maybe this paper did not get enough attention. because it's only conducted, I think, in mainland China. That's it. So maybe this did not get enough attention. Yeah, I think I will ask Claude. Claude से पूछते हैं क्या सीन है इसका, क्योंकि अगर ये अलग अलग टाउन जा रहे हैं तो भाई ये ग्रुप अलग है, ये ग्रुप अलग है. टाउन्स को अगर हम ABC कर लेते हैं. Did Sir Zain solve this question? Because if he did, I'll ask him also. So we will start our group 1 from 3 men. No, not necessarily. This is May, June 2025, paper 5, variant 5. Achha, let's complete part D and then let's stop. The 7 men stand in line for a photograph. 2 of them are brothers, George and Harry. How many different arrangements are there of the 7 men in which there are exactly 2 men between George and Harry? Okay. So पहले हम George को खड़ा कर देते हैं, फिर हम 2 blanks बना देते हैं, फिर let's place Harry. And how many men do we have? 1, 2, 3, 4, 5, 6, 7. Okay, now, so we're going to do 1, 2, 3, 4, 5. 5 factorial into 1, no, wait a minute. 1, 2, 3, 4. 5 factorial into 4. So 5 factorial into 4, what's that equal to? That's equal to 480. And do not forget the possibility that George and Harry can swap also. Okay. George and Harry can swap. So we're going to multiply it by 2. So what's that equal to? That's equal to 960. There we go. Okay. So I guess that's it. That is it. इसको हम यहीं तक रखते हैं. ठीक है. अच्छा देखें, क्वेरीज तो आप लोगों की एंड नहीं होंगी. ठीक है, क्वेरीज तो आती रहेंगी. There is always going to be one question which you might think is more difficult than the previous one. So the queries will keep on coming, but I think it's time we pull the plug. Okay, it is time we pull the plug. iPad है बेटा, iPad 12.9 Pro, I don't know which one it is, ठीक है, but it's working fine. So yeah. So I genuinely appreciate your efforts. Thank you, Vanya, I appreciate it. Thank you guys, thank you. So where can I find this? Okay, I'll upload this solved worksheet, ठीक है. But मैं साथ में ये भी बता दूं कि I have an objection with this question, ठीक है. So I'll just type it here for the record. अच्छा, मैं ये share कर देता हूँ आप लोगों के साथ the solved version. I will encourage you guys to solve the remaining questions, ठीक है. Solve the remaining questions of this PDF. Majority of the questions we've dealt with, so you guys will be able to solve them. ठीक है. Tomorrow inshallah we'll have a syllabus run through, and मुझे एक बात और बता दें कि tomorrow should we do those variance and coded mean kind of questions? Yes or no? You guys want to do that? Because if you want to do that, then we'll have 2 streams. And tell me, what time do you guys get done with the exam tomorrow? Those of you who do have an exam, tell me what time do you guys get done with it? Those are easy and basic. $5:30, okay. So 5:30 pe if you're back, then so let's target 5. Let's target 5 so that we can start by 5:30. ठीक है. Business paper is 1 hour 30 minutes long. So if it's 1 hour 30 minutes, then how do you get done by 5? Do you have 2 papers? Wait, I think Sir Zain भी कुछ stream कर रहे हैं, so I need to coordinate with him also. What time is Sir Zain streaming tomorrow? He is streaming at 1 p.m. So I think he will also probably stream for like 3-4 hours for sure. So let's start at 5. ठीक है. So 5 से 7 हम रखते हैं. अच्छा ये बताएं, is your S1 exam AM or PM? Is your S1 exam AM or PM? PM. Oh, it's PM. No, ठीक है. So we can keep the stream late at night also. So tomorrow, inshallah, we'll have a stream at 5. Most likely, there's coded mean, all that kind of stuff. ठीक है. Then we'll have another stream for the syllabus run through. Okay, the syllabus run through will be short and to the point. Obviously, don't expect me to cover the entire topic from scratch in that stream. That's not possible. ठीक है. बट आज के लिए काफ़ी है. टाइम मैनेजमेंट भी मैं कल ही बताऊंगा आप लोगों को. ओके, जब कल सिलेबस रन थ्रू करेंगे ना तो उसके एंड में बताऊंगा आप लोगों को टाइम मैनेजमेंट कैसे करना है. ठीक है. सो दैट्स इट फेलोज. सी यू गाइस इंशाल्लाह इन द नेक्स्ट क्लास. सो टेक केयर एवरीवन. Allah Hafiz. No, please do not watch this stream for ad maths. Okay, I repeat, do not watch this stream for ad maths. Stay away from it. In fact, run as far as you can for as long as you're not in A levels. ठीक है. So take care fellas. See you tomorrow inshallah. Allah Hafiz. Good luck all those who have their exam tomorrow, and get a good night's sleep so that your brain is fully functioning tomorrow when we're doing S1. Okay, so take care fellas once again. Allah Hafiz.